Hey, Good evening to all respected dignitaries, guests, esteemed faculty members, and dear participants. I am Parul Gupta, an assistant professor in the Department of AI at Vidya Jyoti Institute of Technology, Hyderabad, and it's my pleasure to welcome you all to this AICT Training and Learning online 6-day faculty development program on the revolution of large language models in artificial intelligence from 18th November to 23rd November 2024, organized by Department of Artificial Intelligence of Vidya Jyoti Institute of Technology, Hyderabad. On behalf of VJIT College and the entire organizing team, we sincerely thanks AICT for their generous sanction of rupees 1 lakh towards this faculty development program. This supports reflects AICT's commitment to advancing quality education, fostering innovation, and empowering educators with the latest developments in the artificial intelligence. Once again, a very good evening to all, and thanks to all the participants for choosing this FDP. On behalf of the entire organizing committee, I would like to express my gratitude to our management, Dr. Palla Rajeshwar Reddy, Secretary and Correspondent, Mrs. S. Nilima, Joint Secretary, Dr. Sai Baba Reddy, Principal, VJIT, Hyderabad, Dr. A. Padmaja, Dean, Ranking and Accreditations, Vidya Jyoti Institute of Technology, Hyderabad, Mrs. Sai Lata, Academic Coordinator, Vidya Jyoti Institute of Technology, Hyderabad, Mr. R. Venkatachalam, Senior Administrative Officer, Vidya Jyoti Institute of Technology, Hyderabad, Dr. A. Obilesu, Head of the Department, Department of Artificial Intelligence, Vidya Jyoti Institute of Technology, Hyderabad. I would like to extend my heartfelt congratulations to our esteemed coordinator, Dr. Anusha Ampavati, Associate Professor, Department of Artificial Intelligence, Vidya Jyoti Institute of Technology, and co-coordinator, Dr. Ram Babu Pemula, for their outstanding efforts in making this faculty development program a reality. Their dedication, meticulous planning, and commitment to the excellence have been crucial in bringing together this enriching learning experience on the revolution of large language models in AI. Before we proceed with today's session, I would like to take a moment to introduce our esteemed institution and the department hosting this program. About Vidya Jyoti Institute of Technology, VJIT was established in 1998 by Vidya Jyoti Educational Society, created by a group of committed academicians and enterprising educationists. VJIT quickly won the confidence of the parent community and their students to become one of the select destinations for the future engineers. VJIT is an autonomous institute under UGC accredited by NAC with A plus grade approved by AICT and permanently affiliated with JNTU Hyderabad. CSC, ECE, EEE, Mechanical and IT departments are the accredited with Tier 1 and Civil Engineering is accredited under Tier 2 by NBA. The institute offers 10 BTech, 6 MTech, and MBA programs. The institute has received 1.5 crore rupees research grants from DRDO, UGC, and DST. The faculty members are actively engaged in research work and publish their findings regularly in standard national and international journal and conferences. Institute is well equipped with the state of art infrastructural facilities with a built up area of 22,000 square meters. About Department of Artificial Intelligence, Intelligence Department was established in 2019 with an intake of 60 students and the intake was increased to 120 in 2020. The department is presently offering a BTech course in AI. The Department of Artificial Intelligence has received AICT, ATAL FDP grant and DST grant. The Board of Studies of AI department is having strong industry and academia representatives from Microsoft, EPAM India, and United Online Software Development Private Limited. It aims to groom the students in careers who can rapidly integrate and synchronize their use of sophisticated computer software and programs in addition to specific skill sets to support and lead projects in robotics and autonomous automation in AI. To begin this session, we would like to hear from the coordinators who have worked tirelessly to bring this event together. Now it is my pleasure to invite our coordinator, Dr. Anusha Ampavati, Associate Professor, Department of Artificial Intelligence, VJIT, to address us. Your support and hard work have been invaluable to this initiative, and we are eager to hear your thoughts, ma'am.
Thank you, Parulman. Good evening, everyone. This is Dr. Anusha Ampavati, Associate Professor from a Artificial Intelligence branch at VJIT. I'm delighted to welcome you all to this FDP program, the Revolution of Large Language Models in Artificial Intelligence, organized by AI Department, Vidya Jyoti Institute of Technology. It is a privilege to have a distinguished group of educators, researchers, and professionals gathered here today. Before starting, I would like to thank a moment in thanking of our management, Palla Rajeshwar Reddy Garu, and Nilima ma'am, and Dr. E. Sai Baba Reddy sir, and then Chelam sir, and Dr. A. Padmaja ma'am, Dr. Obulesh sir, Associate Professor and Head of the Department, and Dr. P. Rambabu sir, Coordinator of this program. As we know, the field of artificial intelligence, particularly in the area of natural language processing, has been remarkable advancements in recent years. In LLMs like OpenAI's, GPT, ChatGPTs, Google Bird, and others have revolutionized the way we interact with technology, transforming everything from research and content creation to the teaching and learning process. So mainly this FDP aims helps us to with a foundational understanding of LLM and their potential applications in both academia and beyond. Whether you are already familiar with these models or you are just starting to explore them, these methodologies improve student engagement and assist in research. We are confident that insights and skills you gain from this FTP will be invaluable in your teaching journey and contribute to overall growth of our academic community. I encourage you active participate, asking of questions and share your own experience during the sessions. Let's make the moment of this opportunity to learn and grow together. Once again, thank you all of you for joining us today. We look forward to an engaging, insightful, and enriching experiences with you. Thank you.
Thank you, Dr. Anusha ma'am, for your valuable insights and encouragement. It is now my privilege to invite our esteemed head of the department, Dr. A. Obulesu, Professor, Department of Artificial Intelligence, Vidya Jyoti Institute of Technology, to share their thoughts with us. Dr. Obulesu has been a guiding force behind this FDP program and has continuously supported initiatives that foster learning and growth within our department. Sir, we are grateful for your leadership and the encouragement, and we look forward to hearing from you. I request our head of the department, Dr. Obilesu sir, to address us. Please, sir.
Am I audible?
Yes, sir, you are audible.
Yeah. Thank you for all the participants who are joined for this ATAL FDP, which is conducted by Department of AI, Artificial Intelligence in VJIT Autonomous College. VJIT is right now is recently celebrated 25 years birthday. In this, Department of AI started in the 1999. Now, Department of AI is right now is worth of Myself got 1 crore 18 lakhs DST project. And then previously, Department of AI celebrated on ATAL FDP with a worth of 3 lakhs 50,000, which is offline. Right now, Department of AI got 1 lakh worth of worth from AICT. That's an online ATAL FDP on name of Dr. A. Anusha and Rambabu Garu. First of all, I would like to congratulate all the participants who are joined for this program. Coming to the concept, like LLMs, large language models in AI. Right now, everybody know it. Like they go for ChatGPT or Gemini AI. Basic thing is that LLMs only, large language models only. These LLMs are to do only two actions. One is extractions, data extractions, and one more is the data analysis. One thing is text analysis and text extraction. Only these two things that can be done by LLMs. Recently, advanced for these LLMs, there is a computer vision LLM models out there. Like computer vision point of view, like image related and video related point of view also, there are so many LLM models out there. Right now, current industry related point of view, how to extract the data from the text, how to analyze the data from the text. Next one is that how to extract the data from the images, how to analyze the data from videos. These are only two things. These are very, very, very important as of the industry needs. That's why the Department of AI is conducting this ATAL FDP on large language models. There are so many awesome, eminent professors out there, eminent resource persons out there who are going to be speak on LLMs, large language models. Today, two speakers are going to speak what is the strength of LLMs, and then one more thing is that what is that? How can you implement LLMs? Like this, every day, coming 6 days, every day two speakers are going to be speak about how to analyze the data, how to extract the data from either it is a text or a video or images. So that is the main concern of this FDP. Hope all the participants try to understand, try to analyze, try to extract all this data from images and text and then videos. So I request you all the participants, please utilize this program. Please, I request all the participants every day. Attendance is mandatory, I think so. Dr. Anusha madam, is it mandatory, right?
Yes, sir. Yes, sir.
So as per ACT norms, please, there is some certain rules and regulations over there. So all the participants, I request you, please participate. Please join all these events, all these programs, every day events, please. And there's end of this week, there should be some feed every day. End of the day, there is a feedback, and then moreover, end of the week, end of the program, there is some text is there. So I request you, all of you, attend it continuously and gain good knowledge from this LLMs, artificial intelligence. So once again, I congratulate Dr. A. Anusha ma'am, Dr. Rambabu Garu for getting this program from AICT at FDP. And moreover, I congratulate all my Department of AI faculty who are supporting for this program, for making this much success and making all the participants to attend and then doing of all the activities. So from here, I request all the participants, please join every day and learn something more. Join. So only one theme is for me is that join every day, learn something. That's what I request you all the participants. Please try to utilize this opportunity for enriching your skills in terms of LLMs. LLMs is everybody know it, no? AI is right now is small things. Now next feature is a generative AI. generative AI right now already started, already 80%, 90% generative AI is started. Now still we are in LLMs. As a personally, I share you that is that we are learning very basic things every time, every day. But thing is that you should be advanced. You should be advanced. You should be advanced, like, if you know the basics, obviously you can enrich yourself in the new direction level. Okay, there's a main there's the main intensive or main objective of this program is that you should get some basics on of LLMs, which is essential for understanding ChatGPT and Gemini AI. And tomorrow, OpenAI is releasing so many, like not only this LLMs works on only text processing, but computer vision models are also coming. Computer vision models also coming. Like, computer model visions means that which are working image and video. The LLMS, this LLMS is working on only text processing, but tomorrow and future, some of the models, LLMS models are coming, which are works on images and videos. So this is the basic for understanding coming advanced technologies. So I request all the participants. First of all, I would like to congratulate all the participants who are joined for this program, and thank you for all the participants for joining this program. This coming 6 days, any things, any problem, please share in a group. We are very every time, not only 24/7, every time we are available. Any issue regarding of you or any problem of you, we will ready to resolve that issue. So hope you understand. Thank you all of you. Thank you very much for giving this opportunity. And thank you very much for all the participants. And thank you for all the management people who are joined. Dr. Sai Baba sir, Dr. Padmaja madam, Dr. Shilata madam, and Chalam sir, who are joined for this program and encouraging this program from Department of AI. Thank you, all of you. Thank you so much, all of you. And have a good knowledge for this tonight. Thank you, all of you. Have a good day. Have a good knowledge. Thank you.
Thank you very much, Dr. A. Abulish, sir, for your inspiring words and for your unwavering support and guidance. It is now my great honor to invite our respected Administrative Officer, Mr. R. Venkat Chalam, sir, to address us. Mr. Chalam's visionary leadership and unwavering dedication have been instrumental in shaping our institution's growth and success. His commitment to fostering an environment of excellence and innovation is truly inspiring for all of us. Sir, we are grateful for your presence today and eagerly look forward to hearing your valuable insights. I request our Administrative Officer, Mr. R. Venkat Chalam, sir, to address us. Sir, please.
Thank you. Thank you, Parul Madam, for giving this opportunity. Let me first congratulate Dr. Anusha Madam for getting this FDP. Maybe, as Oble sir told, it should be a very good opportunity for all the participants to learn and get some subject and knowledge from it. Thank you, Madam. Thank you so much. Hello.
Thank you very much, sir, for your inspiring
Yeah.
words and for sharing your vision with us. Now it is my honor to invite Dr. A. Padmaja, our esteemed Dean of Ranking and Accreditations, to share her thought with us. Dr. Padmaja has been instrumental in driving excellence and quality across our institution, and her dedication to upholding high standards is truly inspiring. Ma'am, we are delighted to have you with us today and look forward to hearing from you. I request our Dean of Ranking and Accreditations, Dr. A. Padmaja, ma'am, to address us. Ma'am, please.
Good evening, all of you. And first of all, I would like to congratulate Dr. Anusha for receiving this grant from AICT. And also today, it is a great day for VJIT. Today morning, we have inaugurated one in AI domain and geospatial data analysis. And evening another FDP with online and that is also in AI domain. And also I would like to congratulate the entire team of Department of AI and Dr. Oblesh and Dr. Anusha, Dr. Rambabu and other people who are helped in happen this event today. And I hope all the participants from various states, I think many of them have outside also have participated and registered for this, would immensely benefit from the sessions planned online. And also at the end of the FDP, I think all of you will have a takeaway from this domain, emerging domain on revolution of large language models in AI. And thank you very much for giving this opportunity to speak on this occasion.
Thank you very much, Dr. A. Padmaja ma'am, for your insightful and motivating words. We deeply appreciate your support, encouragement. Thank you once again, ma'am. It is said that no duty is more urgent than that of returning thanks. I sincerely thank our college management who continuously encourage us for gaining the knowledge through various programs. Dr. Palla Rajeshwar Reddy, Secretary and Correspondent, Mrs. L. Nilima, Joint Secretary. Our heartfelt thanks to Dr. E. Sai Baba Reddy, Principal, Vidya Jyoti Institute of Technology, Hyderabad, Dr. A. Padmaja, Dean, Ranking and Accreditations, Vidya Jyoti Institute of Technology, Hyderabad, Mrs. G. Srilata, Academic Coordinator, Vidya Jyoti Institute of Technology. Thanks to Dr. Obelesh Sir, Head of the Department, Department of Artificial Intelligence, Vidya Jyoti Institute of Technology, Hyderabad. Now it's time to thank our program initiators who worked hard to bring out this FDP today. Dr. A. Anusha, Associate Professor, Department of AI, Hyderabad. Dr. P. Rambabu, Associate Professor, Department of Artificial Intelligence. I would like to thank all the HODs of VJIT, all faculties of AI department, participants, and the facilitators behind hosting this program. Now I request all the participants and dignitaries to switch on their cameras to click a photograph. I request to all the participants and dignitaries to switch on their cameras so that we can click the photographs. Again, I'm requesting you all, please switch on your camera. So there is a one small announcement for all the participants. A test shall be conducted by the coordinator at the end of the program, and the e-certificates shall be issued to those participants only who have attended the program with minimum 80% attendance and scored minimum 70% marks in the test and feedback against the FDP. Now we'll take a short break to allow everyone a chance to prepare.
No voice, madam, no voice.
Yeah, I request all the participants, please switch on your video for a small 1 second photograph. Grid view we are going to on.
Again, I'm requesting, please switch on your cameras, please.
I request concerned people to take a grid view, ma. Manisha, ma'am,
Sir, we have taken the photograph, sir.
grid view.
Yes, sir.
You got a grid view, no?
Yes, yes, sir.
Yes, sir.
Yeah.
Hi everyone, good evening.
Rambab sir, please. Rambab sir, who was taking a photograph, please take a grid view of
Yes,
the
sir.
participants.
Yes, sir.
Right?
Right, sir. Over, sir.
Thank you. Thank you very much. One more thing, just I want to add, like, actually, you got a permission from AICT on 11th. Confirmation is on 11th. But tentatively, actually, we are applied on 18th only. Tentatively, while applying, we are giving the dates tentatively 18th only. But AICT is approved on 11th, I think. Rambab sir, am I right? 10th
sir.
night, I think so.
Yes, sir.
But no, from 11th to this day, we got 350 registrations. We got it. Just I want to share with that. That's what feel of VJIT. That's what emotion of the VJIT. That's the emotion of Department of AI, Department of AIT, AI department. So that's what we feel. It is a little bit of a great success, a great achievement, as from VJIT point of view and Department of AIT. AI. Of course, some I request all the participants. Some of you putting some messages like approval point of view. As of AICT norms point of view, our Anusha madam and Rambabu sir is acting. So please wait some time till up to your approval. So, but one thing you should remember, we should give approval for everybody who are joined here. So once again, I congratulate Dr. Anusha ma'am, Dr. Rambab sir for making this event more success from Department of AI, Vidya Jyoti Institute of Technology, Autonomous, Hyderabad. Now, any queries? Now, I think so. Next program is maybe speaker is ready to join.
Sir, already joined, sir. We'll start.
Joined?
Yes.
Right. Parul ma'am,
Yes, sir.
shall we start?
Are you
Yes,
guys
sir.
able to hear me?
Hello?
Yes, Chinigar. Yes. You're
Okay,
listening.
thank you.
Actually, today only two concepts is that what is LLM and then how to implement LLMs. The first day, what we planned. This is a very clear picture for all the participants. Comprehensive. Today, Chinni Krishna sir is giving comprehensive, completely unblocking of power of LLMs. And second one is that how to implement LLMs. So these two things today you are going to hear. Now, hand over to
We are now,
Parul madam.
thank you, sir. We are now ready to begin session 1 of day 1 of our FDP on the revolution of large language models in AI. I'm honored to introduce today's first guest and resource person, Mr. Chinni Krishna Chikata Marla, Vice President Technology, Broadridge. Mr. Chinni will take a session on unlocking the power of LLMs, a comprehensive guide to tokens, prompt engineering, and enterprise applications.
Okay, thank you. Should I
Mr.
get
Chinni
started?
is a seasoned, let me introduce.
Sure,
You,
go
sir.
ahead.
Please, sorry. Mr. Chinni is a seasoned IT professional and solution architect with more than 25 years of experience in this field. His career is marked by innovative strategies and solutions that have significantly impacted IT services and solutions across various areas, including solution architecture, software development, machine learning, AI, and cybersecurity. Mr. Chinny's ability to navigate the dynamic IT environment has enabled him to deliver critical solutions for businesses effectively. Beginning his journey at TCS in 1999, he contributed to the BFSI domain, developing and managing multiple products until 2005. Since joining ADP Broadridge in 2005, Chinny has played a pivotal role in bringing products from the conceptual stage to full production, while spearheading key technical initiatives at an organizational level. His passion for combining creative and analytical skills to solve complex problems underscores his commitment to technological innovation and excellence. I humbly request Mr. Chinni Krishna Chikati Marla, sir, to take the proceedings of the session. Please, sir.
Thank you. Thank you for the introduction. Good evening, everyone. Let me just quickly share my screen. Let me know if you're able to see the screen.
Now we can see.
Okay, perfect. Thank you. Thank you for giving me the opportunity. Today's session, I'll start with what an LLM is. Then we'll look into what LLM tokens are, little bit around the prompt engineering, and then jump on to how enterprise applications can be built using two main patterns. The first one is the RAG. Second is what we call it as NLP to SQL, natural language processing to SQL-based queries. These are the two patterns I'll try to cover in next 45 minutes to 1 hour. So let's start with understanding of what large language model is, right? What does a large language model do for you? So basically, when you talk about a large language model, right, it's what it does is it predicts what's the next best word that can complete the sentence or the context that is being provided to the large language model. So for example, if you look at the screen, right, the question here is the boy went to the dash, right? And there are various options: cafe, hospital, playground, park, school. And then which word to pick up, all these are valid. Which word to pick up depends on the context and then how it looks at picking up the word and starts filling that particular token. So these words are nothing but a combination of multiple tokens. We'll look at it a little bit down the presentation, but that's what large language model is for you, right? So now if I go back to the next slide, right? So what are large language models? Large language models are neural networks trained on massive text data sets to understand the process and generate human-like text. So what do we mean by this? So neural network is a classification algorithm, if you understand predictive AI. So given the context and the data that is around that particular context, what it tries to classify it is what is the next best word that can come in that particular sentence. And it goes through that iteration of steps to arrive at the next word. And that's how they fill the entire generation content and they generate the new content as part of this. And what these LLMs are is like they are trained on billions and trillions of parameters and then the data set, which is like the internet knowledge across multiple domains, multiple languages and all that stuff. We'll look at some of those attributes and other stuff subsequently. But these models operate at a scale, and that's what is important, and that's what is transforming the industry in terms of how LLM works. So there are key four elements that drive what an LLM is. First one is the model. When we say model, it's an identifier in terms of how the model works, what is the type of the model, how many parameters it can process, how many layers of data it needs to process before it can get, and all that stuff. So that drives the architecture of the model and then the identification of the model. Second is the context window. The context window basically talks about the amount of information the model can process in a single iteration. When I say single iteration, we'll look at what iterations is and all that stuff. Again, this drives in terms of what the model is. So when we looked at the previous example, right, we talked about the boy is going to. So the context is 4 or 5 words there. But depending on the model, the amount of information it uses to determine the next token is what talks about the context window and other stuff, right? And the hyperparameters basically control in terms of how your model can operate and what it can do. Some of the things are temperature, top to frequency penalty and other stuff. When you look at temperature, it's like how creative it can be. The lower the value, the models are not creative. They will try to do the same thing, but if you give a higher temperature when accessing a model, it tries to be as creative as possible and then generate the text. So that's how you control in terms of how the LLMs can operate and do their work. And the last part of this LLM framework is the prompt and the instruction. We'll talk in details about this, but this is the instruction and the prompt you're giving to the LLM, which helps us in terms of understand what is there in the question and how it needs to operate on the data that is being provided. So that's this is basically the definition and the key parameters that drive the large language models. And when we talk about large language model, right, what does these 3 words mean? So if you we'll start with the last. So when you look at the model, right, we already talked about the neural networks. So neural networks are nothing but a mathematical representation of a various models and a data set which computers can understand and all that stuff. So the machines can understand. And these are derived based on the various data elements and all that kind of stuff. And when you talk about language, specifically for language tasks, what are the type of language tasks and other stuff? We'll look at details, but it's like, can I summarize? Can I generate a poem? Can I do any other thing? Anything related with the language, if you want to do it, those are nothing but the language tasks. And these are done by transformers. We'll look at what transformers are also down the line and why these are very large. The reason why these are very large is if you look at the number of parameters each model talks about, LLM models talks about, is like 2 billion to 1 trillion parameters. What do we mean by 2 billion to 1 trillion parameters is if you look at any statistical expression or a neural network, right? You have, or a predictive AI, you have what we call it as features that determine in terms of what the output value is. So if you look at try to represent ML algorithm in an equation, you show something like x equal to a plus x, y, b, z, and all that stuff. So there are like 2 billion attributes of parameters that they determine to just say what would be the next token. So that's where the processing power that is required and to build these models and train these models are very expensive. And that's why these are called large language models. Now, before I go, I know all of you use your mobile phones. You do a lot of typing on your mobile phones. Now, if you look at your keyboard and typing any sentences and all that stuff, right? You see certain words emitting on top of your keyboard, depends on your keyboard on the mobile, which starts emitting in terms of saying what would be the next potential word, right? That's a simple example of a language model, but that doesn't understand what is called as a large or internet knowledge and all that kind of stuff. But that's also an example of a language model, right? So now let's move on in terms of let's understand in terms of what are the language centered tasks that are typically involved in a language, right? First and foremost thing, language is used for communication or information sharing or informed. It understands the world at large. It's like today I'm delivering a session in English because you guys understand English, you understand what this is. So the media through which we communicate is the language, and that's where the information is shared and all that stuff. That's the first part of the language. Second is the reasoning, right? So using language, you can reason in terms of why this is happening, why this is not happening, and all that stuff. The simple example is if it is raining, I'll take an umbrella. It is raining, we can conclude that I'll be taking an umbrella, right? These two sentences, if you look at, there is a reason, right? I'll take umbrella when it is raining or when I know that it is going to rain. So there is a reason attached to why I'm carrying an umbrella. So these are the type of tasks that you can explain through a language. And the next one is the emotions. I think all humans, we have a lot of emotions, happy, sad, angry, hate, love, many more emotions that we can carry and express using the language and the tone and other stuff. So these large language models will also be able to showcase some of those. And the discrimination in terms of saying whether it's right, wrong, correct, or various other categories, if you want to put it, you can use language to say this is right, this is wrong, and all that stuff. So these are some of the things that we communicate when we are dealing with any language. And then if you look at this sentence, right, Sachin Tendulkar took guard at large. He looked at the non-striker Sunil Gavaskar to see if he was tense. So if you see all these things are coming in there, right? When tense and all that stuff could be an emotion, right? Because Mohammad Siraj was the fast bowler, there is some fear. So there is a reasoning around why there was a fear. And there is the information that is provided in this whole of this sentence. So when you combine all these things into sentences, there is some meaningful content that's get generated, right? Similarly, if you look at language in terms of other words, what it is and how we can learn from the language is diction. So when we say diction, there are like nouns, verbs, and other stuff which tell you in terms of what these are. And there is a meaning attached to some of these words. Like when I say Jack, I typically, because you know about the language, you know Jack is a man, blue is a color, jacket is a cloth, so on so forth. So there are various meanings for each of the words that are involved in the language, and understanding of all these meanings is helpful for the large language model to emit in terms of what it is doing. And the sentences are a combination of the words which arrive at a meaning in terms of saying how things are related, how words are correlated to each other, and all that stuff. Finally, the context. So when you look at the Jack and Mark were partying in a club, there was a shooting in the club, found a dead body in a blue jacket, must be Jack. So this is this basically. Sorry if you're not. Okay, thank you. So basically, based on the initial two statements, right? When you say you found a dead body in a blue jacket, you are identifying from the context that is provided, it must be Jack. So that's what the context is. So there is certain information that is available. From that information, you are trying to infer in terms of what the particular meaning is. So the context talks about that. And the last part is the grammar. So basically, I think all of us understand the grammar. We went through how the sentences can be constructed, how well it needs to be written, various parts of the speech and other stuff. But large language models need not necessarily be grammatically correct, or they don't deal with grammar. But rest of the language constructs is what is important. And those are embedded into the language models for them to work, right? So this is what the language is. Now, when you look at a language-centric task that is given to a model, right? If you read this, I'm giving some text in terms of saying that originally designed for parallel processing and all that kind of stuff. And finally, I'm asking you in terms of saying, if the technology device then elucidate a funeral, how does it? So basically, are you guys still able to hear me?
Yes, yes.
Yes.
Yeah. Okay. Perfect. Thank you. So if you look at this context and the passage, right, I'm giving certain information around some GPU and electronic processing and all that stuff, and I'm asking it to generate a text based on how Donald Trump behaves and all that stuff. So now if you look at some of these examples and ask the LLM to be as creative as possible and generate certain content, right, it gives you some of these things, right? For that to generate this, right, it has to understand all the language constructs that we talked about. And also it has to have the internet knowledge of who Donald Trump is, what a GPU is, what electronic circuit is, and all that information. So it's a combination of the information and knowledge constructs that drives in terms of how the content is generated. And all these help us in terms of completing language-centered tasks and generating new stuff and all that stuff, things within the large language models. So as I said, all these are the parameters that are driving the modeling language around the LLMs. How are they doing it? This is called as the architecture that is driving this is called transformers. I think you might have heard the word GPT, generative pre-trained transformers. Pre-trained is basically the models are pre-trained on the internet knowledge or the knowledge base that has been provided to them. Generative is where they are generating the new content in terms of what is required to provide in the context. And the last part is the transformers part. That's what we'll look at next. So what is transformers? So this is the simple representation of a transformer. So as a human being, right, when I look at a sentence or when I'm processing a sentence, we try to do that as a sequential methodology, right? Right. My name is Chinni Krishna. You will not process this sentences or sentences parallelly and then determine some of the context. So even when you're reading a book or when you're talking to someone, you're processing the information in a sequential manner. But when you look at large language models, they can process this text or sentences or tokens in a parallel. That's what this paper is all about. Attention is all in you node paper in 2017 that is driving all the GPT and the LLM models that was presented. So how information and text can be processed parallelly and make meaning out of it was what was driving this one. And that's what the transformer architecture drives about. So what, even though it is doing parallel processing, based on the context and the data that it is using, it identifies and focuses on the relevant parts of the input and does the parallel processing to generate the output and shows us in terms of the sentences like humans. So as humans, we are doing sequential processing, but these models are doing a lot of parallel processing. As you can see, there are multiple chains that you see over here, and then it is emitting these output probabilities. And as I've shown in the first slide, it picks up the highest probable word or a token and then starts emitting it into out as a thing. So this is the transformer architecture that is driving the entire large language model. Now, moving on. So what are tokens? I've been talking about tokens, right? Tokens is a next word predictor. So basically, they predict what is the next word that has to come out of this one. So let's look at these, right? So it's basically token is it's a representation or a chunk of characters that is represented numerically or as a sequences. And a token need not be a meaningful word uh, or a letter or a character. It can be anything. It token need not be a complete word size, right? And even if you look at if you look at the language model, right, A, B, C, D, E, F, G, H, and all that kind of stuff, how many words we can prepare this 26 characters is very huge. And with the dictionary of so many words that is there and the context and then the uh, everything that is involved in terms of how you form a sentence, it's very difficult to predict the next word. So what these models does is they break down the entire text and the knowledge into tokens, and using those tokens, that each token is converted into a numerical representation, and the tokens are used to create what we call it as neural networks, and they use multiple layers of neural networks which are used to predict the next word. That's where the tokens help you. And how this tokenization is done for the entire knowledge base and then the input questions and all that stuff varies from model to model. If you are interested in terms of understanding how these tokens work and all that kind of stuff, I would advise you can look at an open source project called Tick Token. The Tick Token it's like calculating in terms of what is the token size involved on a given text. And there are some libraries that are libraries and files that are available which tell you in terms of how tokens are made for a particular LLM. You can look at those, right? And these tokens basically are the building blocks of LLM processing. As we discussed, it can be words or parts of words or the characters themselves. And the context windows limit how much text models can process. So when we have been discussing about the context multiple times, I'll talk about the context a little bit later again. But it is like context is one value or the volume of the information that the model can take and then start emitting the next word. So that's the size of the context that it uses. So currently, most of the models can start from 2K to 128K tokens. I think they are improving every day. So I think they are able to process more. When we say 128K tokens, they can take that much part of input, break it into chunks, and then start doing parallel processing and predicting the next words, right? Generally, average what I've observed around the LLMs is most of the cases, 3 characters could be 1 token or 2 characters, depends on the model. But generally, it's around this is the size. So how many words are there which is of 3 characters in English? Very few. But if you see, even they are constructing bigger words and all that stuff, they are driven by using the tokens of smaller elements and all that stuff. So they don't understand the meaning and all that stuff. But when they generate the tokens, they are able to generate the meaningful word using the language model that we discussed. So let's look at the prompt part now, right? So prompt is the instructions that we give to the large language model. So, and the engineering around how to construct the prompt and what you do, how can you instruct to the LLM model is all called as prompt engineering. So prompt engineering is all about providing the instruction and context on which LLM works on the pre-trained data that they have, and they can give you the output in terms of what needs to be generated, right? So this is basically LLMs. The prompting to LLM is basically to let LLM know that this is the desired output I want, and how you can inform the LLM to give the desired output is all about creating the prompts and generating the prompts. So a well-defined prompts basically contains multiple things. It defines in terms of what are your expectations from LLM, how it can interpret the data that you're providing, what is the output format that you want, and how it can be useful to the user and all that stuff. We'll cover some of those down the line. But these are the various inputs that can go into a prompt that can help in terms of the LLMs to determine and give you the content in a meaningful format that is required, right? And who is a prompt engineer? Prompt engineer is the one who basically uh, does all this prompts, writes the prompts and all that kind of stuff for various tasks that he needs to do. For example, we are having this meeting today and then doing a session. And if you ask somebody to summarize this meeting, right? They have to take the notes, they need to do all that stuff, and then they can finally create a content and then share it, right? You can ask LLM to do the same task by providing the transcript of this particular meeting, and they can able to do it. But to do that, the prompt engineer needs to provide in terms of the context of why this meeting was happening, what has happened in this particular meeting, and then he can also say in what format he wants the output to be coming in. And to arrive at that, he can do a hit and trial. So when I say hit and trial, it's like you write with a certain prompt, you check with a couple of outputs. If you're not satisfied, you can change the prompt, then you rework. And over a period of time, you fine tune and reach a level where you are satisfied with the output that is coming in. So that's the prompt engineer's role that would be involved when we are dealing with LLMs. So this particular role of a prompt engineer is a specialization in the LLM space. And then the key part that a prompt engineer needs to work out is the context length. So if you're dealing with one model to other model, right? If you don't understand the context size of the particular model, when you are writing prompt, it's very difficult for you to say whether it is working properly or not. Having a good understanding of the context size of how the LLM works and what model I'm working on is helpful when you are creating the prompts and all that kind of stuff. Okay, so these are some of the LLM models. I think there are a lot of, and the context size is associated with various LLMs. There are many more models that are available. I've just listed few. So now when we talk about the prompts, the next level is how do I inform the LLM in terms of what I want? So it's like there are two types of prompts. What we call it is a system prompt and a user prompt. User prompt is basically the instruction on what you want the LLM to do. System prompt is the section where you have a lot of information that provides LLM in terms of what you need to do. And typically in a system prompt, you define in terms of how it should behave. So in a simple example is, do you want LLM to keep the responses in brief or detailed, like a 1-mark answer or a 10-mark answer, right? Based on that, it can basically generate that much content, right? And define its role in terms of what role LLM is assuming, because they are trained on the entire internet knowledge on what context they need to interpret this particular question, right? For example, if I'm saying you are an expert in software engineering and I ask it to write a code, it knows that, okay, I am within the software industry domain, I need to look at it and generate the code. So specifying the role of how you want LLM to behave can go into a system prompt. And the last part is providing the context in terms of on what area of software engineering and the brief response or a detailed response do you need. So you are informing that the user will provide a code snippet written in COBOL. Your purpose is to help them understand it. So when I give these instructions and finally I give a COBOL code, it can give me in terms of what is the output that is involved in terms of generating that, responding it back to that. So some of the common patterns and best practices when you are dealing with prompt, writing the prompts or the system prompts is role prompting. As we discussed, define the role in terms of what it is, and how well you define the role drives in terms of how it is interpreting. and the task decomposition. So basically, if you're giving certain input, how you expect LLM to break that into smaller tasks. So if you allow it to explain with an examples and other stuff, it can handle it in a better way and generate better responses for you. And the error handling is basically if it is not able to understand certain context or certain words or some things, how do you want LLM to handle it? So that's also an important aspect of putting it in a system prompt. So it can avoid hallucinations and other things. So hallucination is basically, even if this thing is wrong, it will start assuming there are things that are present and doing it. So it's all about ensuring that you provide the context and ensuring that it can handle certain things better to avoid some of those hallucinations and all that stuff. And do you expect LLM to do any validation on the content it is generating? So LLMs are capable of doing reasoning tasks like what we discussed. So if you wanted to reason certain content and then explain that content and other stuff, it can do that as well and then refine its output if required to give you a better content. So these are some of the things it's better to include it in an LLM, and then on the prompts that are sent as part of the system prompt, and ask instructions so the LLM can respond better. Okay. A simple example of a bad prompt and a good prompt, right? Explain the following code. This is the code that is given here, right? LLM can understand and still do it, but if you give this context in terms of explaining the Python code below using certain delimiters and all that stuff, right? It can do a better job because it understands the context better, and then it will work better for you. So understanding these sections in terms of how these can be provided and then what can be done is very important. So anytime you are working with LLM giving the prompts, ensure that you have relevant information so that it can operate accordingly and jump onto the context as quickly as possible.
Excuse
So
me,
there are,
sir, I have a doubt.
yeah.
In the previous one, just the difference has been recognized as by writing a script that is a Python code.
Yeah.
So that is the one you are giving an information to it to know what type of code you written, because it
No,
can't understand that what is with the syntaxes what we written here.
it can understand. It's not like it cannot understand, but the more context you give, right, the chances that it will not interpret this as a Python code are less, right? If you look at a JavaScript code also, right, it may interpret some of these constructs as a JavaScript code, especially when you're breaking it into tokens and all that stuff, right? And it is doing parallel processing like I explained, there is chances that it could get misleaded. So the correct information that you prompt to LLM will ensure that it doesn't deviate from what you are asking. So by just adding here Python code in the prompt and then saying this below is the Python code using these delimited, I'm instructing to the LLM as part of the context, you're dealing with Python. I know you have knowledge about other things. Don't worry about the other things, right? So it's up to us. As I said, prompt engineering is hit and trial. Uh, will it different? Will it behave differently for this versus this? May not be. But will it behave differently when you're trying multiple times between this prompt and this prompt? The chances are yes, right? If you
And
try
one
the
more.
same code multiple times, it could interpret in a different way. But if you give proper instructions, the chances are it will interpret in a different way are minimal.
Okay, but I don't think so, sir. But because the transformers are getting trained with a huge amount of data.
Yes.
Throughout this one, it can able to differentiate the syntaxes which we written and the keywords which we used in that program style. I think some sort of this kind of a description is still more required for LLM.
See, as I said, right, they are capable of understanding and doing the work. But if you're trying the task again and again, right, do you always get the same answers? I don't know how many times you've tried with LLMs and some of these things. Do you always get the same answer?
No, sir. I'm using the 4.0.
That's it. So
Sometimes based on the question. If I asked the repeated question, I want to know the Fibonacci series program. Then if I asked that use the simple code, or if I used that some complicated code, or if I used this complex sentences like, then it is taking according to the then it is generating. If I'm repeating the same question, it is asking that why is it, what is the generated which I generated earlier is not satisfying your conditions, like it is asking.
Yeah, so those are some of the reasonings that are being done. But the key aspect here is when you are asking this Fibonacci series, right? It's very little information. Now,
no,
if I
just
look at,
example I'm saying,
no,
but
no,
when I asked
I'm
for the
just trying
different.
to, yeah, I'm trying to take the same example, right? So generate a Fibonacci series program. Now, which programming language it need to generate, you did not mention.
No, I'm
So,
mentioning.
No, see the
Sorry
same
to
thing, right?
disturb
Here.
you, ma'am. Excuse me, ma'am. Ma'am, question will get entertained at the end of the session, ma'am.
No, that's okay. Let me just answer it, and then we'll take the other questions in the end because we started the discussion around here. So
Okay.
basically, when you look at that, if you're giving the programming language, right, it is that the chances that it is giving the same programming language are more, right? This is just to illustrate an example in terms of what is the difference. Now, just adding Python, is it completely different? If you look at this for loop syntax alone, right, for I in the range of n or 0 to n minus 1. So this syntax can be applicable in other programming languages also, right?
Yes.
Or phi, it need not be Python. So what is the how the LLM is interpreting this is Python is, it's your guess, right? You may be lucky to get the response that you need, or you may not be, you may be unlucky if it is not interpreting as Python or something else. So the prompt engineering or the prompts, when you are doing, it's better to give it the context that is required. Like I mentioned in the previous slide, it's always better to give this information. So every time when you are asking, you're not deviating from what you want. So the clarity with which you ask, right, the answers you get is also the same. They are, I completely agree, they are capable of giving you the response. They can give you the response which might be meaningful, but with lesser information, without the proper context and all that stuff, if you repeat the same question, not within the same context window, but over a period of time, you ask today, tomorrow, and day after, you might see different answers. It may interpret something as Python and JavaScript and other stuff if the syntaxes are similar, and that can happen. But if you use all the details, the chances that it will deviate will come down. So it's up to you in terms of how you want to try and use it. My recommendation is to give it as much context as possible for the LLMs to operate properly.
Thank you, sir.
Yeah. So there are a lot of prompting techniques. I'm not going to get into this. So basically how you can prompt the LLM and all that stuff. So when you say zero shot prompting or few shot prompting, right? It's like you don't need to understand the knowledge, or you just assume that they have the knowledge. You ask a question and the answer comes back. But there are other things in terms of reasoning, chain of symbol thoughts, and then the examples and other stuff. So these can, where you can give more context to the LLM in terms of how the prompt can be constructed, how it can do the processing, providing certain examples and all that stuff. You can go through some of these patterns. I'm not going to get into all of these things, but there are a lot of techniques in terms of how to you write prompts. So these are various techniques that are involved in terms of the writing the prompts. So you can go through these and then understand in terms of how to write prompts, right? So now this, we looked at what LLMs are, what prompt engineering is, how prompts and tokens are useful, and how LLMs can generate the content. So this is the generative AI space. Now, with all these capabilities, right, when you're working on an enterprise firm or an enterprise application, right, what are the things that you need to do? And then how these solutions can help you in terms of building solutions is what the next section would be. So the first one is basically when you talk about an enterprise solution or a platform, right, you need a very huge architecture that can help and all that kind of stuff. So I've just presented the architecture diagram that we use internally for all our discussions. So I'll not go into the details of this one, but it's basically an entire architecture with various things that are involved with some common concerns and all that stuff. If you're building at an enterprise, do you need your own portal to manage your workloads? What is involved and all that stuff? So there is a lot of engineering, nothing related with LLMs. Same in the service layer, you have a lot of things that you want to do. Will like when a content is coming in or a question is being asked, am I deviating from any governance policies that are set for an enterprise? How do I do that? How do I validate it? How secure is my data? What data I'm exposing to LLM? Am I at risk from data security point of view? Right. So all these things are important. And how am I connecting to LLM? What security is involved? How am I managing my costs? So there are various things that are involved when you want to build for an enterprise. So there are a lot of services and the frameworks that you need to build around LLM to make this happen. I'm not going to get into the details of those things, but just to give you an information in terms of there is a lot is involved in terms of working with LLMs and the building a solutions. I just wanted to present this architecture. Now let's look at an enterprise, right? So when you look at enterprise and working with LLMs, right? If you're a developer or you are a API programmer who is building solutions, right? You're not going to use the web portals or the self-service portals that are provided by LLMs. You interact through APIs. Now, every LLM has their own format. So if you're working with an OpenAI, the way you communicate with OpenAI is different from the way you communicate to Llama versus Claude or any other model. So there are various things that are involved. And with this space that is going on in terms of you see every new model that is coming every day, and then one breaks over the other, and then they claim that I'm superior to other and all that stuff. So there is a chance that you may need to move from one LLM to other LLM and all that stuff. So the biggest or the first challenge you face as an enterprise is which model to use and what format to use. So what we have done as an enterprise is don't worry about the format. Create your own abstraction layer in terms of how you want to interact with the LLMs, standardize the formats, and then use that format to build your solutions so that you using that abstraction layer, you can move from one LLM to other LLM easily. Okay. In addition to building these abstraction layers, you can also build what is called as pre-processes and post-processes, as you can see on the top. We talked about the context, LLM doing its output generation and all that kind of stuff. But when the prompt is coming, I don't want to pass the prompt directly to the LLM. I want to do certain pre-processing. The pre-processing can be in any way, right? It can be in terms of adding additional information if you think that is important, or validating you are not deviating from your IP or some of the concerns. Are you deviating from any governance policies that are set at your enterprise level? All those things that if you want to control and do it, those all can be happened in terms of the pre-processing level. And post-processing is also same. Once the output comes from LLM, how do I use that post-process data or the data that has come out and then use it? So that's what is important in terms of identifying what works for your enterprise, what frameworks can help you in terms of doing these validations, which rule engines you want to use, or can I build an LLM or a AI models itself, when the predictive LLM AI models itself to control some of these things. So if you see my architecture again, you see I've listed certain AI libraries like name entity recognition models or NLP models. These can help me in terms of detecting, is there any PII data in the prompt that I'm sending, and how do I react with the things and all that stuff. It's like, even though I'm working with an AI technology, can I use other AI related stuff to ensure that my solution is more robust, secure, and all that stuff is the other way, right? So that's very important for an enterprise level. So this is what you need to build as a foundational layer thing. And once you identified how you want to do and all that kind of stuff, then you need to decide which LLMs to work with. As I said, there are a lot of LLMs that are available. And how do I choose which LLM to use? So each enterprise basically defines in terms of what are the key parameters on which they want to assess the LLMs. So if you look at, I've listed down here how general a model can be. For example, if I'm in a healthcare domain and I work only in healthcare domain, do I need a model that deals with an internet knowledge or knowledge beyond LLM, beyond internet, or can I look at a model that is specific to healthcare? The choices are us, but again, you have a decision that needs to be made over there, right? Which one to use? Maybe if you're confined only to healthcare and you want to work only in healthcare and you're using a model that works specializes in healthcare, the cost of that particular model might be lesser, or the infrastructure that is to run that particular model might be smaller compared to a general model which can do a lot more tasks, right? Availability for commercial use. So when you're building solutions, you obviously want to sell it. So what are the licensing that these models provide, how they can help you out, what is the cost involved in terms of using those models and all that stuff. And the privacy and confidentiality is how these models have been behaving on themselves. So basically, a simple example is when you ask a particular model how to create a bomb, how are they responding it? What moderations they are doing it? How responsible they are in terms of they are doing it? Otherwise, what happens is you need to do certain elements on your end if the models themselves are not doing it. So you have to assess those aspects in terms of your governance and other aspects in which can help you in terms of doing it. And there are other things in terms of the context, model size, latencies that are involved, and the flexibility it provides to fine tune. Fine tuning is like if I provide my own data, can I create my own model by adding this? Because these are pre-trained models. I cannot do training, but I can do fine tuning by providing additional information to the model on my context and other stuff. And how good it is in terms of the industry, where does it stand among other models and all this stuff. So these are the various parameters that are involved in terms of determining which LLM models you want to use. And once you determine the LLM models, then using the framework that you have built, then you can start building the applications. Now, when we talk about building generative applications, right, I have just tried to represent this in a simple way here. So basically, if you're doing just a prompt engineering, ask a question and get an answer, which is a simple application that you are trying to build based on a context, you can use what is called as a base model or the foundational models, and you can do prompt engineering and get your work done. And predominantly, this operates only on the overall knowledge that LLM has gained, right? And the second level is the fine tuning or transfer learning. When we talk about the fine tuning and transfer learning, as I said earlier, if you have your own data or IP and you want to put it on the model, create a new model by fine tuning that thing. It's like an FAQ document or a questions that you have, all that information you want to put it onto the model and create a new model for yourself. Then you can use that particular base model, fine tune the with your internal data, create a new fine tuned model. And these sort of models can be used for overall knowledge because they already have the internet knowledge. Any internal knowledge that you have, questions around your internal knowledge policies and all that stuff. And any tasks that you want to do could be well suited for internal task oriented related tasks can also be performed by this methodology. The next one is the retrieval augmented generation model. This is basically, I don't want to expose my data outside to the LLM. I want to keep it internal, but I still want to have the capability around that. Then that's where the RAG based approach will come into it. So we'll talk a little bit more around this. These are also can work on oral knowledge and the internal task orientation as well as the internal knowledge. The difference between fine tuning and RAG is you're not exposing your data to the external model. And fine tuning involves a lot of effort. And then with the speed at which the models are changing, and if you want to upgrade them from one version of the model to other version of the model, you still need to fine tune. So fine tune again and use the next version of the model. It doesn't come automatically. So there are pros and cons of these things. So whichever works for you, you need to make a judgment call and take it. In my recommendation so far has been until and unless you are 100% sure, don't go for fine tuning because the span at which the models are available and then the speed at which they are changing is very fast. So the effort that is involved is very high. So you may not get the required ROI if your data is very huge. So prefer other thing if it works for you than fine tuning. There are pros and cons of all both of these approaches, but you can decide which one works for you. So when we talk about RAG, which is retrieval augmented generation. So basically, as I mentioned, RAG combines LLMs with the knowledge base to generate accurate and contextual response. So how does it work? So basically, there are four standard steps in terms of building a particular RAG model, a RAG pipeline. So when you talk about document processing pipeline, it's like what is your internal knowledge, documents, and all that stuff. You read those documents, break those documents into smaller chunks, and you convert those chunks or text snippets into what we call it as embeddings or a vector store, vectors, which is a numerical representation of the data. And you store that vectors in a vector database. And whenever a query is coming from a user, you convert that query again into a vector. You do a similarity search on that particular vector database to extract in terms of what is the context and what is the potential chunks that can typically have an answer. You put all that into a prompt and ask LLM to answer it based on the data that you have provided. So that's how you need not expose the entire internal knowledge to the LLM, but exposing only the relevant content to the LLM to get the answers is all RAG. So it's a combination of all these four things where you process the document, build a vector database, and then you create a prompt which can say in terms of how you want to generate the content, and ask LLM to generate the content is where it is involved in terms of generating the questions. And there are a lot of use cases that you can do around RAG. I've listed some of those here, like documentation and knowledge base is the predominant one, where you have a lot of technical documents or standard operating procedures and various other elements that are involved. So you can use this models or this pattern to build solutions around this, chatbots or other things around this. Customer support, same story. So if you have a lot of FAQs that are documented against standard procedures, a lot of tickets that are generated, can I use these information to handle my customers better is the other use case where you can do through RAG. And legal and compliance. So basically, any analysis that I want to do in terms of how I'm writing the contracts, what are missing, is it deviating from certain things and all that stuff you can do through the RAG as well here. Or I have already done certain contract, I am getting a similar contract that I need to do. Can I use this copy and create a new content based on existing contract? So those are some of the things that you can use RAGs for. So these are some of the industry use cases that you can work on using RAG. And the second one is the NLP to SQL. So when we talked about RAG, right, it's more about the unstructured data, documentation, and then things like that that are available for you internally, which you don't want to expose to LLM, but you want to work with that knowledge to build solutions is all RAG. NLP to SQL is a lot around the structured data. As an enterprise, right, you're creating a lot of data or you have a lot of data, but I cannot do anything with the data until and unless I have build a interface or build a data warehouse or any other thing. The other way around is use an NLP to SQL based of methodology. When we talk about NLP to SQL, it's natural language processor to SQL. So instead of writing a SQL, I can ask LLM in terms of saying, can you give me the average pass rate over last 5 years? And you give it access to the database and the database structure, it can give you a query where you are exposing only the metadata to your LLM. When I say metadata, the structure, the schema, some of the high values, low values, what you think is suitable for your database, and then the domain, and ask LLM to create me an SQL query. So it can give you your SQL query and you can run that SQL query against your database and start emitting those values in whatever fashion you want. So this is the other way of developing a lot of solutions if you have a lot of internal data on which you can use LLM capabilities to build certain solutions. In this, again, the key elements are query understanding in terms of what is the intent with which you are asking that question, which entity do I query, basically, because you have a lot of databases, a lot of data elements, which one to query and all that stuff. And within that entity, which columns are important to this question? How do I do? Is there a join that I need to do across tables and all those things? That's all goes into the prompt, but that's what your query understanding is what you need to do in the prompt and then give it. And the schema management is the other stuff. How many tables you have, what are the relationships, so that it can do the joins and all that stuff. All this information should go onto the prompt. And finally, the query generation, which is the output the LLMs provide. So the query generation basically helps you in terms of coming out with the output, and then you can validate. You can ask LLM to do the output validation and do that particular stuff. And a lot of use cases around NLP to SQL, basically the business intelligence or the data exploration or any other things that you want to do around the data. The use cases, domain specific use cases would be around what data and domains you are operating in. But in general, if you look at data exploration or business intelligence around the data is what you want to look at it and then do these elements. Build solutions around this is the other use case. So these are the two patterns I wanted to cover. I think this might be my last slide. Yes, that's right. So this is what I wanted to just talk to you and then provide you the inputs around the LLMs and various use cases and how you can work on an enterprise. So any questions or any other thing, happy to answer now.
If anyone is having any query, they can ask now. Anusha ma'am, allow participants to...
Yes, ma'am. I'm giving 1 minute. One second, ma'am.
All the participants, please wait for a while.
Just now again, ma'am. Check from your end.
Now all the participants can mute themselves and they can ask the questions.
Sir, I have a question.
Yeah, go ahead.
Yeah, for the hands-on practice as a beginner, do you suggest any material or any, specific links for that?
Basically, there are multiple things that are involved. Again, it depends on what you want to do with hands-on. If you're more interested in prompt engineering and other area, I would recommend try with the playgrounds that are provided by the LLMs themselves. But if you're really into the programming and all that stuff, there are other resources. I'll try to share some of those little later on with Anusha. Maybe she can share with you. I'm sorry, I'm not able to recollect the good resources right now, but I'll try to share those offline later with Anusha, and then maybe she can share with you.
Yeah, sure.
Hello, sir.
Hi.
Hello, sir. I'm audible.
Yes. Go ahead.
Sir, since you have mentioned a different model,
Yeah.
RDG something, so how these models are differ from one another, and so for LLM, I mean, which one probably it depends upon the domain it will be vary, or how, sir?
Okay. So basically, I think there are two questions, right? How does models vary and what is RAG? RAG is just a pattern for building solutions using LLMs. It's called retrieval augment generation. It's not a model. It's like a design pattern using which you can build solutions. When you look at an LLM model, if you look at Gemini from Google, GPT from OpenAI, Llama from Meta, and Anthropic Claude, these are the various LLM models. So when I talk about the various models, there are a lot of vendors that are building models, and then there are a lot of solutions that are available. I've just quoted some of the famous ones. So how these differ from one to other is how they interpret the tokens, what tokenization mechanism they are using, and what language they have been trained on, and the other stuff. And if you look at Llama or GPT or any other thing, right? If you go to their site, you will see when they talk about that particular models and all that stuff, you'll see there is a context size that is specified in terms of how much this model can process. You may see like 32K, 128K, and all that kind of stuff. So that talks about the capability of the models and all that stuff. Until what date the data is trained on, because these are pre-trained models. Is it trained till 2023 or 24 or 22? Till what date it is trained? And the third parameter I talked about is the number of parameters that the LLM is involved. Like if you look at Llama, you will see 7B, 70B, 13B, 31B, and other stuff. These are like 7 billion parameters on which the model operates. So to determine the next token, they process those many number of parameters to determine the next token. So the more number of parameters, the higher capability the model will have, but also they will do a lot of more processing, and to run that model, it requires a lot more capacity. And the other bit I did not touch upon is what we call it as a multi-model versus a language model. Multi-model is they have the capability to understand images and other stuff. In addition to just the language itself, they can interpret some data from other elements other than the plain language. I don't want to use English alone because they are capable of doing other languages as well. But instead of plain text, they can do others also. Those are called multi-models. So these are the various things that you need to look at and determine which use case you're working on and decide which model is more suitable for me to work with.
Sir, I have a query.
Yeah.
In
Thank
the
you, sir.
generally in
Excuse
a
me,
deep
ma'am.
learning models.
Excuse me, ma'am. Sorry to interrupt you. While asking the question, please switch on your camera also.
Okay.
Thank you so much, ma'am.
Ma'am, sir, I would like to ask that in a deep learning, generally when we are going for a fine tuning, we are going to take the pre-trained weights and we will tune it with respect to our data. So
That's correct.
is such kind of possibility is there with the LLM models such that, as you told that if you have a internal data and you don't want to
Yes.
expose it.
Yes, it's possible to fine tune the models with your internal data and all that stuff. That's what I talked about. So basically, the fine tuning can work in multiple ways. It's basically you need to create a Q&A sort of document and then say for these questions you need to provide the answers on this way and other stuff. And how you can fine tune a particular model, each one have their own mechanisms. So depending on the LLM model you choose, the fine tuning mechanism varies. You can do that, and it's possible to do that.
Is there any high computational missions are required for this also, sir?
Definitely, yes. To run large language models itself, you need high computation machines.
No, we are
But
taking the help of Google Colab and this SageMaker
yeah,
for generally for the fine tuning of deep learning models. So
that's
is
it.
that kind of is possible with this fine tuning of LLMs also?
Okay. The answer is yes. If you're using cloud, simply yes, there is a lot of capacity and power available in clouds to do it. But just to let you know, right, just to give you some stats, right, if you talk about a 7 billion parameter model, right, how much memory does it require is very huge because it needs to load those many number of parameters and then determine in terms of what's the output is and all that stuff. So the machines that are required to do this are also very powerful. If you're talking about SageMaker, I've done fine tuning using SageMaker, and then we have used, if I remember correctly, the machine name P4D or something, which is a huge machine of 96 GB memory or more, and then a lot of CPUs and GPUs involved. 96 cores or memory, I forgot. P4D is the model that
Colab
I've
it
used.
is A100 and TPU series with 100 GB it is providing.
That's right. You see that's for if you're working with a 7 GB, 7 billion model or a 13 billion model, it may work with that. But if you're going into a 70 billion parameter model, it may not work with that configuration. You need higher the configuration. So the more capable the model is, it requires more infra, and then you need to work using those. So, but fine tuning is possible, and how you can fine tune each model varies from one to other. OpenAI basically provides a SaaS-based approach because you can directly do it on their website by loading the content and all that stuff for trials. But if you're trying to do on your own, you can do with SageMaker. We have done that for Llama models, and then we have created our own fine-tuned versions.
Thank you very much.
Thank you so much, sir.
So this is Zakir Hussain, and I have a question, sir.
Yeah.
So this is regarding the multimodal that you have mentioned. Like multimodal, can we do multiple inheritance from different models? I mean, different already the base models.
No, the answer is no. When we say multi-model, right, it's the capability that we are talking about. It's not like coming from multiple models.
Yes.
So when we talk about the capability, we are talking about what the model can do. In addition to processing the text, it can also process certain images.
Yes.
And then give you the response. So in context of LLMs, when we are talking about multi-models, it's not like I'm combining multiple models and then trying to do inheritance or create a new model. You never do it because all these models are trained on similar data set, which is internet knowledge, right? What is that you gain by creating an inheritance of one model over the other model? I don't see a use case, at least as of now. So inheritance is not the right thing to talk when you're dealing with models. But there is a chain of thought processing that you can read about it when you want to deal with multiple models. So that could be a potential use case where you can try different models. You can chain the output of one model into the other one or one section into the other section to generate the output and do that. People have tried it. So you can try some of those if you want to try with multiple models.
Multimodal attention mechanism through it is possible, sir.
Yeah.
Okay, thank you. Thank you, sir. Thank you.
Sir, very good evening, sir. This is Oblish, Dr. Oblish from VJIT.
Yeah, good evening.
Sir, I want a computer, actually LLM models are with respect to text related, image related and video related. I hear like, computer vision models also is there. Is there any?
That's true. Computer vision models are also available, but LLMs also have come up with what we call it as multi-model capabilities. So they can process not only text but images and other stuff. So
Is it?
yeah, so initially they started only as text engines, and now they can do much more beyond text also. So computer vision is the one which deals with the media and other stuff, but large language models, they started with text, but they have entered into the next space and all that stuff. They can do much more, and this space is evolving very fast. So keep watching.
Thank you, sir. Thank you so much. Sorry to disturb you, sir. Small announcement, a small instruction. Dr. Y. Ambika disturbing a lot from presentation. Sorry, I'm very sorry. Please avoid such kind of things.
Thank you so much, sir, for delivering such a wonderful session and to clear all of our doubts.
Yeah.
And on behalf of entire organizing team, I would like to extend our heartfelt thanks to Mr. Chinni Krishna Chikati Marla for gracing us with his presence today. Sir, your valuable insights and time have made a significant contribution to this session. Thank you once again, sir, for your generous support and being with us today. Now, I would like to invite our coordinator, Dr. A. Anusha ma'am, to conclude and summarize the session. Ma'am, please.
Thanks for taking your time, Chinni Garu. On behalf of everyone here, I would like to extend our sincere gratitude to Chinni Chikati Marla for the insight and engaging presentation. Your expertise on unlocking the power of LLMs, a comprehensive guide of tokens, prompt engineering, and then applications were truly enlightened. And we appreciate the time, effort you put into sharing such a valuable knowledge with us. We are grateful for the opportunity to learn from you, and we look forward to applying these insights in our own work. Thank you once again, Andy. Thank you.
Thank you for giving me the opportunity. Thank you all.
Thank you so much, sir. Thank you. Take care.
There is a small announcement for all the participants who joined late. At the end, a test will be conducted by the coordinator at the end of the program, and the e-certificates shall be issued to those participants only who will attend the program with minimum 80% attendance, scored 70% marks in the test, and feedback against the FDP. So there was the announcement to all the participants, and now we'll have a short break around 15 to 20 minutes, and it's sharp 7:50 we'll join again for session 2. Thank you so much. All.
Madam, request you to share the attendance like after 1-2 days or something like that in between, so that we understand whether it is correctly recorded or not. If there is any mismatch, also we understand.
Yeah, sure, ma'am. On WhatsApp group, we will share all these things.
Yeah, sure. Thank you.
Thank you so much, ma'am.
By end of this session, we'll share the link, ma'am. Don't worry. Hello?
Okay, sir. Thank you.
Should we join the same session, sir, by 7:50 p.m.?
Yes, ma'am. Same link for all the sessions. Same link for all the sessions. Okay.
Okay, sir. Thank you, sir. Thank
you. Have a small break.
Can you share the PPT also, please?
We will collect and we will share with you, ma'am.
Okay, sir. Thank you so much.
Just now the session is completed, na? Just I will collect from the speaker.
Yeah.
With his permission, I will share with you.
Okay, thank you so much.
Don't worry, sir.
Madam, everything will share in the WhatsApp group. Don't worry. Okay, na?
Yeah.
Sir, every session is having that attendance link, or end of the session only you have to send that attendance link?
Actually, every session having attendance, sir.
Okay.
Actually, on the first day, just we are not given.
Sir, automatically it is taking, sir. We are exporting that files and everything we are taking. After completion of the total session, we'll check and we'll get back to you, sir. Okay.
Yes. In Zoom meeting, we are taking attendance, sir.
So we'll be we'll be here at 7:50 again. Thank you so much.
Thank you, Parul Gupta, ma'am.
Thank you so much, sir.
Have a small break.
Thank you so much, ma'am.
Meanwhile, anybody having any doubts, please. We are here to hear your voice. Parul Gupta, madam, Dr. Anusha, madam, Dr. Rambabu, sir, we are here to hear from your voice. Any doubts, any clarifications, or any extensions, or any enhancements? Anybody? We are waiting for the voice. We are waiting for your voice. Any suggestions from your side? We are extremely very sorry if there any delay or anything else. We are very sorry. From your side, any suggestions, please? We will rectify. Anyway, have a good time. Have a small break. Thank you.
Thank you, sir. Welcome back, everyone. I hope you had a refreshing break. We are now ready to begin session 2 of day 1 of our faculty development program on the revolution of large language models in AI. In this session, we will dive deeper into transformers, the backbone of LLMs, and our expert speaker, Sangeeta Yamisetti, will guide us through the concepts and applications of this fascinating field. We are truly honored to have a distinguished guest, Ms. Sangeeta Yamisetti, with us today to grace the day.
Hi everyone. How are you all doing?
Ms. Sangeeta
Fine,
Yamisetti,
thank you.
software.
Yes. Am I audible, guys?
Sangeeta Yamisetti is an accomplished IT professional with 10 years of experience in the industry, specializing in machine learning and artificial intelligence. Known for her expertise and innovative solutions, she has received numerous appreciations from companies and clients for her impactful contributions. With 7 years of focused experience in natural language processing and generative AI, Ms. Sangeeta has been instrumental in developing cutting edge applications across various domains. Her ability to translate complex algorithms into practical, real world solutions highlights her technical acumen and problem solving. Throughout her career, Ms. Sangeeta has successfully designed and implemented numerous ML models driving business value for clients by automating process, improving decision making, and enhancing customer experiences. Beyond her technical expertise, she is passionate about knowledge sharing and has provided hands on training and mentorship to junior developers, fostering a culture of learning and growth within her teams. Ms. Sangeeta's commitment to excellence, combined with her strong technical background and leadership skills, underscores her reputation as a key player in delivering impactful technology solutions. I humbly request Ms. Sangeeta Yemisetti to take the proceedings of the session. Please, ma'am.
Thank you. Thank you, Parul Gupta, for the very good introduction about myself.
Thank you so much, ma'am.
Thank you. Hope everybody are doing great and had a tiresome day, I guess. So today, actually, okay, let me share my screen and share the presentation so that people get. Please do let me know once you guys are able to see my screen.
Yes, visible. It's
Ma'am,
visible.
we are able.
Madam, it's visible.
Screen is visible.
Yeah, thank you. Thank you for it. So today we are going to speak about the topic called transformers, which are the backbone of LLMs. So as Parul Gupta has introduced about myself, I'll just give a very quick introduction. Like I work in APAM Systems as a lead software engineer into ML domain. So yeah, today we are going to have a very good overview about the topic, the transformers, the backbone of LLMs. We'll see what are the agenda topics. We're going to introduce what are transformers, what is the main specific called attention mechanism in transformers, the entire transformer architecture, the main important components of transformer, that is encoder and decoder, and what are the advantages of transformer over RNNs and CNNs. Then I'll be giving about different kinds of LLMs, like we do have the GPT series, and we'll see a very small case study just for an example. And then we'll go to like, how to make use of these LLMs, like we do call it as fine tuning of the transformers for different tasks. And what can transformers, what can these LLMs do beyond the text applications? Some, a very practical example and challenges and limitations of the transformer. So here is the quick introduction. Like I'll tell you the objective of the seminar here. We'll be able to get the overview of transformers. In today, our our goal is to deep dive into the world of transformers, the architecture behind many of the AI models that are revolutionizing the natural language processing today. And you have been probably heard of this or even interacted with the AI models like ChatGPT and the other things like Google's BERT model or other powerful language understanding models. But we'll see how they are going to give us such kind of good information and how they are making our lives easier. How we'll look into that perspective as well, and we'll also see how, demystifying the technology. That means while these models can feel like a black box for us, we don't know what is happening that what is this mystery, and with their massive size and complexity also, how the knowledge is being fed to them, where are they grasping the entire things, all these things we'll see it. And the fundamental concepts behind them are quite approachable. It is very understandable for us once we get the basics of it. Then after, we'll go ahead, we'll demystify the transformers by breaking down into different components, the core ideas, in a way that it will be easier for us to understand. Then what is their significance in AI? Like, transformers have completely reshaped how we approach language and even tasks beyond text, such as we do have these transformers in the industry of vision, speech processing, and they are no longer powering chatbots, but they are the backbone of nearly all advanced NLP applications. And this seminar will give you a solid understanding of what are transformers and their architecture. Fine. Here, what are the key takeaways for the students? It's like, basically we'll start with the exploring the key ideas, like the attention mechanism, which is an idea that allows transformers to selectively focus on different parts of the input data, which is essential for understanding the language model. If you say a few sentences, the model should be able to identify what are the most important words or most important contextual language that is present in that particular text given to us. So how they are going to identify it and what is the mechanism, we'll be seeing it. The basic concepts, like this is called attention mechanism that we call. I'll let you know in detail. And then we'll also cover self-attention, multi-head attention, and other fundamental concepts that make transformers so powerful. And the other key takeaway is that we'll cover the transformer structure. Then we'll dive into the architecture of a transformer model itself. You'll learn how it's built layer by layer from encoders to decoders. And we'll discuss how the components fit together to allow the model to understand language in a way that it feels remarkably human-like. And we'll compare the structure to older models like RNNs and LSTMs to show why transformers represent such a significant advancement in the real world things. So, and also we'll get to know what are the real world applications. Like, finally, we'll look at real world applications of transformers. I'll share a few examples of how they are used in everything for virtual assistants and text summarizations to complex applications in industries. Basically, nowadays, these transformers are, the LLMs basically are mainly used in the health industry as well, health industry finance. And by the end of this session, you will not only have a solid understanding of how transformers works, but also an appreciation for the vast range of possibilities they bring to UI. So yeah, this is all about it. Next, when we go ahead, first of all, I'll tell you, all these transformers are nothing but it's a kind of we'll see how it has got evaluated. So in the evolution of NLP models, the early days of NLPs, we used to call it as n-grams and language models. Like, NLP started with fairly simple statistical approaches that we can say. Like, one of the most popular and early methods for this is n-gram model. Like, if you give a particular sentence, it used to divide this particular sentence into different, we can say n is nothing but the number of set of words that you have to differentiate this sentence into. So this, if you say, for example, 2 gram, that is nothing but a bigram model. The model predicts the word based upon the two words combinations in the particular sentence. And if you say a 3 gram, which is nothing but trigram model, it uses the previous 2 words to predict the next word. Previous 3 words to predict the next word. So this is how we do it. Next one. What are the limitations? However, when we have gone this early NLP models, what is the single limitation that brings us to this picture is that they had significant drawbacks. Like, since n-grams only consider limited context, like just a few words before the target, they are not effective for understanding. For example, if I say a longer sentence, like, okay, fine, I am learning this particular topic today. Okay, I'm learning LLMs, or I'm learning the architecture of transformer today. It has helped me.
Ankita ma'am, sorry
For
to interrupt
example,
you.
this is a particular.
Ma'am, can you please keep a slideshow?
Sure. Just a minute, I'll get to the slideshow. Let me reshare it so that I can get to the slideshow. Fine, just let me know how you are able to see it. Is it fine? This is our slideshow. Just give me 1 second.
Ma'am, your presentation was fine. You just do the slide share.
Sure.
Go to the view mode.
Yeah. Let me know once it is in view mode actually.
Yeah.
It is in?
Now it is fine. Yes, ma'am.
Okay. This particular thing, so that's the issue with it. Like, I do wanted to share some other source as well. Let me give a final try, just a minute. Okay, so if I keep the slideshow, I'm not able to do anything else here. One minute. Okay, fine. Let us go ahead with this. So as I was speaking about, a few things, am I audible to you guys?
Yes, ma'am, you are audible.
Yeah, fine. Thank you. So yeah, I was speaking about like how the things that we are going to do. So first, the evolution of NLPs in the meanwhile. Yeah. So as I was saying, like we used to have this n-grams, bigrams, and everything, but now it's a different story, all of thing for us. So it is something like it is beyond the 10 grams. It just not only consider about the context of the few words, like 2 or 3 words before it, but it should consider the entire context of the words. So that is the main drawback that we used to see in the previous models. In the in the evolution of the models in the NLPs, we used to see the limitation is like these models had significant drawbacks, which like since n-grams only considered the limited for the target, and they are not effective for understanding the longer sequences or maintaining meaningful meaning across the sentences. So this used to be the one. And how did, like from this, from the n-grams, we have shifted to this particular thing called the neural networks. Like the rise of RNNs has happened, introduction of recurrent networks has happened to overcome the limitations of the statistical models. And researchers have developed these recurrent neural networks. Like unlike n-grams, RNNs can process sequence of variable length, which made them particularly appealing for NLP tasks, we can say. Like, for example, how do we do it is that to overcome these limitations, like, and RNNs use their hidden state to remember past information as they move through a sequence. But see, RNNs itself is a very vast topic, topic of transformers. So I'll just brief you out like what does RNNs do. RNNs can process sequence of variable length, which made them particularly appealing for NLP tasks. That means that RNNs use their hidden state to remember the past information. Like there will be some kind of black state in between the things, which makes us quite understanding. Like it remembers the previous context of the sentences and then used to generate the new sentence, making them ideal. These RNNs were ideal for the task like language translation, where context matters a lot. Then there were challenges with RNNs as well. Like despite being a major breakthrough, RNNs still had challenges like vanishing and exploding gradients or common problems during the training. So the training of RNNs itself was a very tedious and it's a difficult task, and are longer sequences because they have difficulty retaining information over time. For example, RNA work fine for a kind of a length of 15 to 20 words, the sentence that contains. But if you go for a paragraphs, or so if you go for some big number of essays, if you give that particular context to RNNs used to fail utterly for them. So that's the main limitation. And this is especially limiting for the tasks that need to understand long range dependencies like translating paragraphs or answering questions based on large chunks of text. So now we have got to our, and also there used to be LSTMs and GRUs. Like we used to call LSTM is nothing but long short-term memory units, and GRUs. For example, long short-term memory networks, how do they work is, they are actually introduced to tackle the limitations of standard RNNs. Like researchers introduced long short-term memory networks that use special structures called gates to control the flow of information, allowing the model to remember or forget information at different points. Like for example, in LSTMs, what it used to happen is that it will specifically concentrate on the required context that has to be remembered, and it forgets the rest of the unnecessary words. So it used to, these gates used to give certain words green flags and certain words red flags to forget and remember few things. And these gates enable LSTM to retain important context information over longer sequences. solving some of the memory issues RNNs face. We also used to have GRUs before these transformers called gated recurrent units. A simpler variant called gated recurrent units was also developed to improve efficiency while preserving the ability to manage long-term dependencies. All these do have their own limitations. So now we'll go ahead with the hero of the topic today, that is transformers. So first of all, I'll tell you why transformers are needed. See, the limitations of RNNs, LSTMs, and GRUs had led our researchers to explore alternatives. And this search brought about transformers included in 2017 by Vaswani in the paper, Attention is All You Need. So this is how it started, the introduction of transformers. And transformers revolutionized NLP by using a different approach called self-attention. And the key innovation here present is called self-attention. Transformers use self-attention to weigh the importance of different words within a sentence, regardless of their position in the sequence. For example, if I say a paragraph which consists of around 50 to 60 lines, it basically identifies the words and for each word, it gives certain weightage. And that particular weightage will lead to the importance of the word in that paragraph. So, and this is a major shift from the previous models because it allows transformers to understand long-range dependencies without having to process each word in a strict sequence. So when you give weightage to particular words, you don't have to follow only the sequential meaning of it. You can always get, based upon the weights of it, you can get the exact context that is present in the sequence. Then transformers not only more powerful in understanding the context, but also much faster as they can process all parts of a sequence simultaneously. So they are much faster in it. And they do have this parallelization and efficiency, like transformers enable parallel processing, which speeds up both training and inference. Like unlike RNNs or LSTMs, which need to process words one at a time, transformers can analyze all words simultaneously. Like this efficiency and power in handling context across long sequences are why transformers have become the backbone of large language models. So yeah, and going to the next slide. So this is a basically example, and before that I'll define transformer. Like transformers architecture introduced by the Google researchers in the 2017 paper, Attention is All You Need. If you go through this paper, you will definitely get a very good understanding like why transformers have been introduced and how do they work. And originally designed for NLP tasks, they have now adapted to a wide range of applications, including vision, speech, and multimodal tasks. And the role in NLP is transformers are currently the backbone of most advanced NLP. Their ability to handle complex language tasks has made them understand model for applications involving understanding, generation, and translation. So all these tedious tasks, our LLMs are going to make it very easier for us. Thereafter, and how did these transformers overcome the RNN limitations? Is that the sequential limitation of RNNs, like traditional models like RNNs and LSTM process sequence step by step, which is the sequential approach, allows them to handle language to some extent only. Now it makes it difficult to capture long-range dependencies and shows down training significantly because each word must be, it slows down the training process because each word must be processed one after the other. And this limits the effectiveness of tasks that require understanding large texts or complex languages. For example, if you give a paragraph of that has around 100 or 200 words, if you wanted to process these words one by one, it takes a longer time for them. And also, it doesn't get the context that efficiently. So this is this limitation is now overcome by the transformers with its parallelism mechanism and also the efficiency by weightage. That is what we call it as attention. And then handling long-range dependencies, like by working on the sequence as a whole, transformers can handle dependencies between words no matter how far they are, how far apart they are in a sentence. For example, two words refer each other in a sentence after around 15 words or around 20. They are 20 words apart, but still they refer each other. In that cases also, the transformer will definitely be successful by giving certain weightage or attention to those words and getting the exact context to what do they mean. And this is the key for understanding the meaning of complex sentences. And where context is spread out over a long distance, something RNNs and LSTMs struggle with. So till now, we just had the introduction of transformers. If you guys have any doubts, please interrupt me anywhere. We'll have a good discussion, then we'll move on with respect to the next ones.
No, ma'am. At last, we'll start question it's.
Oh, okay, fine. Let us go ahead with the next step. So this is what we call it as attention mechanism. Attention. At the heart of the transformers, this is the concept of attention, like more specifically self-attention, I can say. The attention mechanism is what that allows the model to selectively focus on different words in a sequence. For example, here, consider the sentence, the animal did not cross the road because it was too tired. So for a normal LSTM or for a normal recurrent network, the it in this word, we know that when we read this particular sentence, the it here is referring to the animal. But how do the LSTMs or the RNN knows it? So they don't have a good idea about what is it referring to. But in this case, since we are given the attention mechanism, like this attention mechanism is what allows the model to selectively focus on different words in a sequence, even if they are far apart from each other. And they helps the model understand. See, for example, if you see here, there are different weights given for each word in the sentence. Like, for example, is too tired is given certain attention weight, and it's too tired. Like there are different weights that you can see here. In the here, self-attention in simple terms, I can explain you like, think of attention as a way of allowing the model to look around within the sentence and pick out words that are related to the current word it's focusing on. I'll tell you, I'll explain the example. For example, in this sentence, the animal did not cross the road because it was too tired. As I told you before, the word it refers and the self-attention allows the model to understand that it relates to animal, despite other words coming in between. So this is essential for understanding context and meaning in language. And advantages of this self-attention is that self-attention enables transformers to consider each word in the context of the whole sentence, not just in the context of the previous words that it is giving. So, and rather than just the nearby words. And this is not only improves the model's understanding of language, but also allows it to assign different levels of importance to different words in technical terms. And each word can attend to other words, which lets the model weigh relationships more flexibly. So this is what this self-attention mechanism does. Going ahead, this is a pictorial representation of the transformer architecture. So just have a look at it once. There are many unknown terms here. I know it. Just for 10 seconds, have a look at it. We'll go through what does each do. Fine. So basically in the transformer, if you see this small, there are two boxes, I can say, in our one. There is a small one and a bigger one, and there is a link between these, the inputs box to the outputs box, right? So the inputs box, which we can say, which is an encoder part, and the output parts is nothing but the decoder part. So the transformer architecture consists of two main parts. One is the encoder, which is responsible for understanding and processing the input sequence. And the other one is a decoder part, which is responsible for generating the output sequence. I'll tell you what does this exactly mean. The encoder takes the input text, encodes into a contextual representation, like a set of vectors that capture meaning and relationship between words. And the decoder uses this representation to generate meaningful output by attending the encoder's output and previously generated words. For example, here as to the input, I have passed the same sentence saying the animal is too tired and sorry, there was some sentence, right? The animal did not cross the road because it was too tired. So let us consider now when you pass this sentence as an input, this encoder, what does it do is it actually converts that particular sentence into a vector that captures the meaning along with the context of the sentence. And when this vector is passed to the outputs, the decoder that we say, that decoder will generate the appropriate, like uses the same representation to generate the meaningful output, taking the encoder's output as the input and also the previously generated words. So this is what happens. And here think of the encoder as a reader analyzing a book and creating detailed notes. For example, encoder firstly in a native language, if I want to explain, think it as a reader which analyzes a book and creating detailed notes about it. For example, I have read a book of 100 pages and I have prepared a notes of 15 pages around, which has the entire content of the book. And now, while the decoder is a writer, and now this decoder uses this particular short notes created by the encoder to create something new like a summary or translation. Now it precises and gives you the summary or it translates whatever it felt like. This is how they work. And the I will tell you in detail what does this encoder and decoder work. So the encoder's primary job is to analyze the input sequence and convert it into a meaningful representation. The steps in the encoder are input embedding. Input words are converted into dense vector representations, like numerical values that capture the semantic meaning of words. And this is the first part, input embedding. The next part is positional encoding. Like since the transformer process words in parallel, it needs positional information to understand the order of words in a sentence. Like positional encodings are added to word embeddings to preserve the order. Now we do have self-attention mechanism, which helps the encoder to understand the relationship between words. For example, in the sentence like the animal, like the animal did not cross the road because it was too busy. Too tired. Here, it is related to the animal, right? So the encoder figures it out. And it also figures it out like what is the reason that it is not crossing the road. So something like that. And we do have a feed-forward network. Like after self-attention, the encoder applies a neural network layer to define the presentations. To add more meaningful and context integration of both of them happens in feed-forward network. Okay. So now we remember, like in the encoder, we do have 4 parts. That is input embedding, positional encoding, self-attention mechanism, and feed-forward network. Now coming to the decoders. The decoder's job is to generate output based on the encoder's output. So what are the steps in the decoder is marked self-attention. That means it ensures the decoder attends only to previously generated words while predicting the next word. So my encoder has given me some output. It has generated some vectors for the few specific words. Now I'll read only those specific words and will predict my next word, what it is going to be. And encoder-decoder attention attends to the encoder's output to gather context from the input sequence. So this is what it does. And output generation is after processing the input representation and previously generated words, the decoder generates the next word in the sequence. So it is as simple as that. Encoder here, nothing but it reads a given book to you. It just, concises the entire information and gives it to in a short form. Like it gathers both the context and the meaning, the entire meaning. And based upon this one, the decoder is going to generate the next set of things. And yeah, for everything, there are two sides of coin. So we'll see what is LLM architectures and their transformer stack. Like LLM is nothing but based upon the combinations of transformers that we use, there are different large language models that have been introduced. LLM is nothing but large language model. Now we are going to see what are the types of large language models that are present, their architectures and their transformer stacks. How did they use? Okay, so like the key differentiation here is not all transformer models use the decoder structure. Modern large language models like adapt the transformer architecture for specific tasks. Like BERT is nothing but bidirectional encode representations from transformers.
Ma'am, your voice is breaking, ma'am. Sangeeta.
And it focuses on generating output text by predicting the next word in a sequence. And the applications of this GPT models are text completion, chatbot responses, and summarization. So yeah, this is a bit of introduction about LLMs, different types and their transformers. Okay. So now I'll explain the transformer architecture. Here, the encoder stack. Here is nothing but self-attention mechanism. If you can see in the figure around this particular one, the multi-head attention, add layer and normalization, again, the same thing is happening like until and unless. First of all, if you take a sentence, like here we are saying some sentence, let us take a previous sentence itself. Like the animal did not cross the road because it was too tired, as it was too tired. So if you first of all pass this sentence to the transformer, it divides the sentence into particular tokens and embeds it, like it converts it into vector. It's just vector is nothing but a combinations of ones and zeros. So I'll be showing a very detailed one step by step. How is it going to act? So here, if you see, the encoder stack is a multiple layer of self-attention, like multi-head attention layers, and feed-forward networks are nothing but neural network layers for refining representations. Each layer processes and passes information to the next. And the decoded stack includes masked self-attention, looks at already generated works, and encoder-decoder attention connects the decoder to the encoder's output. Feed-forward networks. And this, first of all, I would like to emphasize here the multi-head attention. Instead of a single attention mechanism, transformers use multi-head attention to focus on different parts of the input-output sequence simultaneously. And this allows the model to capture various aspects of relationships and meanings. So now we'll go to the practical task. For example, here, if you see in our mobile also, depending upon some sentences, like if I say like, hello, how are, like it is suggesting you words, right? You are, or else how are things. So all these are correct suggestions only. So it happens something like that. For example, if I say the command is write a story, the response can be once, or write a story after once upon. So write a story once upon a time. It is completing our sentence. And if you see here, the transformer architecture, this is how it works. Like I was explaining a bit before, right? So this one, First of all, the input as soon as you pass the input text, it is converted into tokens, and those tokens are nothing but divided into certain number of words, and these words are getting embedded, and these embeddings are added a little bit of meaning and context in the positional encoding. After that, they pass to the attention and feed forward networks. Okay. So here, I'll tell you with a practical example. Once you write a story as an input to your transformer, first of all, the tokenization happens like dividing the sentence into 3 tokens. Like each word I can say, write a story. So after that, what happens is that the transformer, this one, it for the word right, there is a different embedding. For a letter, there is a different embedding. For story, there is so these are nothing but like that I can say vectors. So these are vector embeddings that we call. There are different set of embedding mechanisms, which is a completely different story, which we can take it as a different part of the seminar as well. And after encoding, we do call it as a positional encoding. Like the right letter comes in the first place. Right word comes in the first place of the sentence. A letter comes in the second place. Story comes in the third place, and the full stop comes in the fourth place. So this is positional encoding. And if, for example, in our sentence, if write repeat twice or thrice, then we would, mark all the positions for it, like 1, 6, 9, something like that. After this, and this transformer is nothing but is a concatenation of many transformer blocks. Each one of this is composed by an attention component followed by a feed forward component. So I'll be definitely giving you a source to continuously go through it, like what is attention, what is feed forward, all those things. Okay, so yep. After this, for example, if you see, I'm just showing an random example for you for the sake of attention. Money in the bank here, and we don't know what see, we recognize that okay, money is a noun, bank is also a noun. When you give attention to this particular both words, money, bank, you don't get the sense of it. So when you say money in bank, the attention goes towards the words in between also. Then it has got the contextual meaning in the sense, okay, the cash is in the bank. That's how the pictorial representation does it for you. And here is the transform, how does this transformer do? Write a story. Now you have provided this positional encoding one as an input. The transformer, after the softmax layers, it has certain output of words out of
Ma'am, your voice is not audible, Sangeeta ma'am.
RNS process word by word, making them inherently.
Ma'am, your voice is breaking. Can you please check your internet connection?
Meanwhile, I want to do one announcement. We will be sharing 2 feedback forms for session 1 and session 2 on WhatsApp group. Please fill it and please fill it before 11 p.m. Thank you so much.
Am I audible? Am I audible now?
Yes, ma'am, you are audible.
Yeah. Okay. Thank you. Yep. So let me continue with the advantage of transformers. Like RNNs process sequences word by word, making them inherently sequential. This limits their ability to leverage parallel computing effectively. For example, instead of we just sorry, is there any disturbance?
Yes, ma'am.
Is it
Your
still
voice
there?
is breaking.
Okay, my internet connection is working fine.
Now it is clear, ma'am. Now your voice is audible, ma'am. You
Is
can
it okay
continue.
now?
Yes, ma'am. You can
Okay.
continue.
Okay, fine. And this limits their ability to leverage parallel computing effectively, slowing down training and inference. Now, transformers, on the other hand, process the entire sequence at once using the self-attention mechanism. This allows for efficient parallel computation, speeding up training and making it feasible to handle massive data sets. And real-world impact is that in large data sets like those used for training GPT models, transformers can process millions of sequences much faster than RNNs. And coming to the handling longer sequences, RNNs struggle with longer sequences due to vanishing gradient problem, where long-range dependencies are lost. Transformers use self-attention, which directly connects every word in a sequence to every other word. This makes it easier to capture relationships between distant words, even in long documents or paragraphs. Example, for a document summarization task, RNNs may lose track of the context established in the earlier sections of the text, but transformers can retain their context effectively and capturing contextual meaning efficiently. Transformers consider the entire sequence context at once, using self-attention, enabling them to capture relationships between words in different parts of the sequence. RNNs and CNNs are limited by their design. RNNs process sequences linearly and struggle with distant dependencies. CNNs rely on convolution filters, which are effective for local patterns, but cannot efficiently model long-range dependencies. For example, in the sentence, the animal did not cross the road because it was too tired, transformers can easily link without losing track of the context. Now, comparison of training efficiency and accuracy. Like training efficiency here is nothing but transformers leverage GPUs or TPU hardware for more effectively due to parallelization, resulting in significantly faster training times compared to RNNs and CNNs. For large-scale data sets, transformers can reduce training time from weeks to days compared to RNN-based architectures. Accuracy improvements due to their ability to model long-range dependencies and contextual relationships. Transformers achieve state-of-the-art accuracy on many NLP tasks like translation, summarization, and sentiment analysis. Example, like on the Glue benchmark, transformer-based models like BERT consistently outperform RNNs and CNNs in tasks like sentence classification and paraphrase detection. Okay. So yeah, this is about our the advantages of transformers over this. One of the practical examples for comparison is that, for example, if you consider sentiment analysis on a data set with 1 million movie reviews, RNN takes 10 hours to train and achieves 78% accuracy, whereas CNN takes 6 hours and achieves 82% accuracy. But transformers take 3 hours and achieves 91% accuracy. So that's how our transformers work efficiently and both, I mean, the fast and accuracy. So now we'll speak about one of the important LLMs like bidirectional encoder representations from transformers, the BERT model. So what is BERT? BERT stands for, as I've written there, bidirectional encoder representations from transformers. This is developed by Google AI in 2018. BERT is a transformer-based pre-trained model designed to understand language better by processing context from both the sides, both the directions. Unlike traditional NLP models that rely on one-directional context, BERT uses the encoder stack of the transformer to grasp the full meaning of a sentence. And why BERT is important? It introduced pre-training plus fine-tuning. Tell you what is fine-tuning and pre-training also, where a single pre-trained model can be adapted to various NLP tasks with minimal additional training. And BERT becomes a cornerstone for state-of-the-art performance in tasks like question answering, natural language inference, and sentiment analysis. And we'll speak about what is this bidirectional nature of BERT and what is it doing. What does bidirectional means? Like most earlier models such as RNNs, GPT processed input in a single direction, like from left to right or right to left. And BERT, however, processed the entire sequence in both directions simultaneously. How words interact in the full context of the sequence. For example, I'll take the same old example, don't mind it please. The animal did not cross the road because it was too tired. A unidirectional model, like left to right, may struggle to determine that it refers to the animal. But BERT processes both directions to establish that it is semantically linked to the animal. So that's the advantage. And why is it helpful is nothing but bidirectionally allows BERT to consider preceding and succeeding words, improving its understanding of context. And this is particularly useful for tasks where precise meaning and relationships matter, such as reading, comprehension, or disambiguation. And popular applications of BERTs are question answering, like BERT powers systems like Google search, enabling them to retrieve precise answers for large text corpus. Example, question like who developed the theory of relativity? The input text, Albert Einstein developed the theory of relativity in 1905. And BERT identifies Albert Einstein as the answer by understanding the relationship between the question and the context. And sentiment analysis, which is used in e-commerce to analyze product reviews, customer feedback, or social media sentiment. Example input, the product is great, but the delivery was slow. For example, let us think one of the e-commerce on the e-commerce application, we have got this respective, review. The product is great, but the delivery was slow. Now, BERT can distinguish between positive sentiment about the product and negative sentiment about the delivery. So, thanks to this contextual understanding. And next, text classification. BERT excels in tasks like spam detection, email categorization, or document tagging. For example, if you give the input as urgent, for example, the mail subject is urgent, your account needs verification. BERT identifies this is like a more like a phishing attempt in spam classifications. Translation summarization, though BERT itself isn't primarily designed for these tasks, its derivatives like T5 and BERTSUM handle them effectively. And the key features of BERT is like merged language model. That means BERT is pre-trained by masking random words in a sentence and predicting them. This helps to understand word relationships in context. And next sentence prediction helps BERT learn sentence to sentence relationships, crucial for tasks like dialogue systems. So this is about BERT, which is a very useful and very basic model for most of the things, tasks that it is solving. And GPT series. Everybody is familiar right nowadays with ChatGPT, and this is the main important model behind the ChatGPT. GPT, which is generative pre-trained transformers. I'll tell you the evolution of GPT models. How did they evolve themselves? GPT-1, which is firstly introduced, the first iteration introduced the concept of unsupervised pre-training followed by fine-tuning. So in 2018, this mainly focused on text generation and simple NLP tasks. Okay, and the architecture is, this is based on a transformer decoder stack, unlike BERT, which uses the encoder. So the main difference here is BERT uses the encoder stack, whereas the GPT uses the decoder stack. And GPT-2, which is introduced in 2019, which highlighted the power of scaling. Yeah, with 1.5 billion parameters, GPT-2 showcased the ability to generate coherent and contextually relevant text over language sequences. Longer sequences. And controversy is that initially it's not fully released due to concerns about potential misuse. GPT-3, which is released in 2020, it has a massive leap. It boosted 175 billion parameters, making it one of the largest and most versatile NLP models at the time. Few shot learning demonstrated exceptional performance with minimal examples, enabling it to generalize across the tasks. And the impact that it had, it paved the way for practical applications in content creation, coding, and more. GPT-4, the recent one, 2023, multimodal abilities. It supports text, image, and code inputs, expanding its versatility. Improved reasoning, better understanding of complex instructions and performing reasoning tasks like summarization and classification. These applications, it has its applications widely used in conversational AI, virtual assistants, and creative writing tools. So this is a quick introduction about evolution of GPT series. Going ahead, fine. GPT uses a main concept called auto-regression. Here, auto-regressive nature of GPT, we'll discuss about this. GPT generates text one token at a time, predicting the next word based on previous tokens. So now, example, if the input is the sky is, so GPT depicts blue, then clear, and so on. So the sky is naturally, we can say blue or clear, but it predicts the blue and then clear. How it works is that GPT does not see the full sentence at once. Instead, it builds context progressively, making it deal for next generation tasks. This sequential prediction allows GPT to create coherent and contextually relevant outputs, even for lengthy inputs as well. So advantages of auto-regression is it maintains logical flow in outputs, mimics human-like sentence construction, and so on. The limitations here is it struggles with global context over very long sentences as it does not revise prior predictions. So this is one of the limitations. I'll show you the practical applications of GPT models. The text generation. GPT excels at generating human-like text for creative and practical purposes. Example, writing stories, poetries, or even code snippets. Like if you give this as an input, like write a story about a hero saving a city from disaster, output is a detailed, contextually rich narrative one. Summarization, GPT is widely used to create concise summaries from long documents or articles. Example, summarizing research papers or news articles into digestible formats. Like input of 5,000 word research article will, once given to GPT, it produces a 200 word summary capturing the key points. Conversational agents, it powers chatbots and virtual assistants applications like customer support, personal assistance, and education. For example, if I say what's the weather like in New York, the current temperature in New York is 65 degree Fahrenheit and clear skies. So that's how GPT, like it is as natural as a human like one. Translation and paraphrasing. GPT can translate languages or rewrite text in simpler language, like translating from English to French or rephrasing a sentence for clarity. Code generation, it can be used in tools like GitHub Copilot to assist developers, like generating Python functions from plain text descriptions. And now we'll go for the visual representation idea. As I was speaking to you about, if you can see this whole picture represents to you the architecture of the entire transformer. But the the orange highlighted one is a GPT style transformer. It uses only the part of the decoder one without this multi-head attention in between the layer. So it basically represents one of the decoder format of the transformer. And let us go for a quick case study. So I'll just show you here. See, first of all, the input layer. For example, I have given the input as a write a motivational quote. Okay, this represents the starting point where GPT receives the text input. Tokenization. What does this do is, as I've shown you previously, the sentence is divided into tokens. Now, write is a token, A is a token, motivational is a token, quote itself is a token. And this includes, the division of sentence into a certain number of words or tokens that we call. And self-attention mechanism. Basically, it highlights like how motivation relates to quote in the sentence. This attention mechanism highlighting how GPT analyzes the relationship between words. The weights for these connections are usually represented using the lines also. And feed forward network, like it illustrates how the processed tokens passes through a feed forward network layer for further transformation. So all these are the simple steps like feed forward, after that the output layer, then we can compare what is the before and after of it. The next one comes, which is a very important topic called as fine tuning. Fine tuning is nothing but the we can fine tune our transformers for different set of tasks. The concept of fine tuning, I'll tell you what is its importance as well. Fine tuning is the process of adapting a pre-trained transformer model such as BERT or GPT to transform the specific task or to handle domain specific data effectively. I'll tell you in a new example. For example, if you have designed a motor that can work, an engine that can work for any kind of car. But based upon that particular engine, our transformer here, and the types and companies of cars, like depending upon the usage, there can be sedans, there can be SUVs, there can be 5-seater, there can be 7-seater. So depending upon your usage, with the same engine capacity, you are making different types of things. So this is nothing but fine tuning of the existing one into your own needs. So the pre-trained models, transformers are trained on massive data sets like Wikipedia and news articles to learn a general understanding of language. Specialized tuning to make the model used for a specific use case. For example, sentiment analysis or summarization or domain-specific tasks. The model is further retrained or fine-tuned on a smaller specialized data set. Okay, and why is fine-tuning important? It allows leveraging the general knowledge embedded in the pre-trained model while tailoring it to solve specific problems. Fine-tuning saves time and computational resources compared to training a model from scratch. It improves model accuracy for specific use cases by focusing on task-specific data and objectives. Just think of a fine-tuning like a training a person who knows English to write legal contracts. knowledge and structure. And this person, can be used for some other purpose also. So you have to train him based upon the domain that you wanted to make use of. And domain-specific tuning. Fine-tuning can adapt a transformer to unique domains such as medical NLP, extracting potential insights, generating radiology reports, or predicting diagnosis from medical records. Example, fine-tuning BERT with datasets like PubMed or Mimic3. These are some popular datasets. Legal NLP, summarizing legal documents, analyzing contracts, or predicting this case outcomes. Here I can give you an example of fine-tuning GPT with a corpus of legal cases. And financial NLP, analyzing market trends, summarizing financial statements, or detecting fraud. Okay, by fine-tuning a general purpose transformer on a data set from a specific domain, the model becomes more accurate in understanding and generating domain-specific language. And examples of this fine-tuning applications are nothing but sentiment analysis, a general purpose, like a pre-trained bot model might understand general language, but struggle with the task-specific nonsenses, such as sarcasm in customer reviews. Fine-tuned model, fine-tuned bot on a labeled data set of movie reviews or product feedback, making it highly accurate for predicting sentiment in similar contexts. Something relates the same to summarizing legal documents or conversational agents, all these things. And now we'll speak something, the transformers beyond text, I can say, like applications in other domains. Transformers are into computer vision as well, like vision transformers that we call them. What are vision transformers here are? Vision transformers apply the same transformer architecture originally developed for text to image data. Instead of processing sentences, vision transformers process images by splitting them into smaller patches, like splitting them into smaller pixels also. Each patch is treated like a token in NLP, and the transformer learns relationship between these patches using self-attention. Advantages of these vision transformers are unlike traditional convolution networks, vision transformers do not assume a fixed local structure, making them better at capturing global relationships in images. They achieve state-of-the-art performance on tasks like object detection, image classification, and image segmentation. Example application of this vision transform is that vision transformer model trained on millions of labeled images. Is my PPT not visible to you?
It's visible, Sangeeta. It's visible.
Yeah. Okay. Fine. Okay. Am I fine with the voice? Is it clear?
Now it is clear.
Okay, fine. Thank you. So now this one image classification, as I was saying, this vision transformer model trained on millions of labeled images can classify objects in photos such as identifying a cat, dog, or airplane, kind of things. Object detection that we say. And transformers in speech processing, like transformer power models like speech to text and text to speech systems by analyzing and processing audio sequences. For speech data, self-attention enables transformers to capture temporal relationships effectively without relying on recurrent connections like RNNs. And a notable example here is Whisper by OpenAI, which is a very good, transformer in speech processing. A transformer-based model for speech recognition that can transcribe audio into text while recognizing multiple languages and dialects. Like we do have our voice assistants like Siri and Alexa. They rely on transformer-based architectures for understanding spoken commands. And transformers in protein folding, like AlphaFold, which is a new concept again. AlphaFold developed by DeepMind guys uses transformers to predict 3D structures of proteins from their amino acid structures. This is something that is related to biology, and the applications are drug discovery, genetic research, all these things. So now what are the challenges and limitations? Like everybody has their own, threshold of the things, right? So the high computational cost is one of the issue. Like transformers require immense computational resources to train due to self-attention mechanism, which scales quadratically with sequence length. This makes training models like GPT-4 or BERT on long sequences or massive data sets extremely expensive. And the impact is that high GPU or TPU requirements to resource. I could say the example is GPT-3 required over 175 billion parameters, demanding thousands of GPUs over several weeks. And the current solutions that we have for this limitation is to have sparse attention mechanism and efficient architectures again. Requirements, transformers vast amounts of labeled and unlabeled data for pre-training to generalize effectively. Gathering and cleaning such datasets can be time intensive and resource heavy. For example, GPT-3 required over 570 GB of text data for pre-training, far beyond the reach of typical datasets for many projects. And the current solution that we have is transfer learning. Pre-trained models like BERT, GPT, and Robota are fine-tuned on smaller domain-specific datasets, minimizing the need for extensive data. And also, we do have data augmentation technique as well, like back transition or synthetic data generation. And difficulty in interpretability. Transformers operate as black box models, making it challenging to understand how decisions are made. This is particularly problematic in high-stakes applications like healthcare or legal system, where explainability is critical. Like lack of interpretability can lead to mistrust or hinder debugging when models behave unexpectedly. For example, a semantic analysis model trained on biased data might predict the wrong sentiment for certain demographic groups, but diagnosing the bias is not trivial. And the current solutions that we have for this is attention visualization tools, like show which tokens the model focus on, providing insights into decision making, all the explainable AI research, all these things. And model size and inference time. The sheer size of transform models leads to high latency and model consumption during inference. Example, running GPT-3 or BERT on mobile devices is nearly impossible due to their massive size and computational demands. Environmental impact, energy consumption required for training large transformer contributes to a significant carbon footprint. This is one of the common things. What are the ethical considerations in using transformers? Like we should consider this bias in training data, like transformers like GPT and BERT are trained on massive data sets collected from the internet, which may include biased or harmful content. These biases are then reflected in the model's predictions. Like a sentiment analysis model might associate certain professions or demographics with negative sentiments due to biased training data. And for this, we do have certain solutions called bias detection, bias mitigation techniques, diverse data sources, all these things. And the thing is potential misuse. Transformers can be misused to generate harmful content such as fake news, a deepfake test, or malicious code. GPT models can be exploited to create phishing mails or misinformation campaigns. And the solutions for this is access controls, usage monitoring, fine-tuning for safety, all these things. And we do have privacy concerns as one of the limitations, like large language models can, inadvertently memorize this sensitive information from training data and reproduce it when prompted. So models trained on improperly anonymized data sets could leak private user data such as email addresses or credit card numbers. Like encouraging responsible development and usage. Developers must prioritize ethical guidelines while building and deploying transformer-based models. Transparency, model behavior, and decision making is essential to build trust with end users. And examples of ethical applications here are bias-free chatbots, content modernization tools, privacy-enhanced NLP. So yeah, this is all about it. And we'll see the future of transformers and LLMs. like upcoming trends in transformers and LLM development, like improvements in efficiency. Current transformer models like GPT-4 require immense computational power, memory, and energy, limiting their widespread use. Now the innovation has come into like it introduced techniques like locality sensitive hashing and reversible layers to reduce memory and compute requirements, makes transformers more efficient by processing longer sequences with lesser hardware demand. Sparse transformers, low rank adaptation, all this is LoRa model that we call it as. And multimodal models, like multimodal models processes and integrate different types of data such as text, images, and audio, enable richer AI experience. And I'll give you certain references for all this where you can go through them. And more interactive conversational AI. Conversational AI is moving toward enhanced interactivity, emotional understanding, and real-time adaptability. Speculating future applications like personalized learning. I can say transformers can analyze learning patterns and tailor educational content to individual students. Healthcare, how transformers are revolutioning medicine, the breakthrough applications, creative industries, all these things. Like how transformers will shape the future AI is the democratizing AI with improvements in efficiency. More organizations, researchers, and individuals will access powerful AI tools, affordable fine-tuning methods, and lightweight methods. All these things will be in place. And yeah, finally, any Q&A? Any questions, please? We are done with the presentation.
Now participants can unmute themselves and can ask the questions.
Good evening, madam.
Hi.
Madam, good evening.
Yeah.
Madam, good evening. Good evening.
Good evening. Good evening, sir. Hi.
Madam, you can say that the transformers is the encoders as well as decoders.
Yes.
So, for example, I want to do some project. The project name is so the project name image caption by using Telugu.
Image
Image
okay.
captioning by using Telugu.
Okay, fine.
But in which I am facing so many problems. That is maybe by using Telugu language, it is complete Dravidian language. Now we are facing some problem. But Telugu, we are using of tokenizing what it maybe this is completely acceptable. But Telugu, we are facing some problem. We can stemming as well, amortization also facing some problems. So that's why we will try to using of transformers. So which one is best suitable for the Telugu language?
Okay, I cannot say like a specific language this transformer particular thing works, but try using this kind of things, like try using multimodal models.
And
For
that's
example,
why I am already using a multi-model transformers.
okay.
Embed also we are facing some problem. That's why I am giving any suggestion.
Okay, for Telugu language you are saying,
Yes,
right?
madam. Yes, madam.
So you want to generate the caption in Telugu language.
Yes, madam. Generally, we are giving the image. Image is input as well as along with the given the 5 captions. In which one is perfectly suitable for the image that can be get some output.
Okay, you are asking me which transformer works better for this.
Yeah. Yes, madam. Yes, madam.
Transformer model works better. Okay, let me just give it a thought. I'm just thinking about the transformers. What
Okay.
all I have to know. Like what this object sentiments aligned, like Oscar, have you tried it? Or M4?
No, madam, I am not trying Oscar. Okay, I will try it.
Oscar and M4C will give you a better result.
Okay, madam. Madam, one more doubt. You can say that when we are using a RNN algorithm, the sequence is very large. That's why we are facing some problem. We can store the data. That's why we go for a transformers.
Yes, partly correct. Yes.
Yes, madam. But in RNN can be failed. Then we go for a LSTM, na? LSTM after that RNN.
Yes,
That, but
both
but
LSTMs
we are facing only
Sir, sorry for the interruption, sir. Sorry for the interruption. Hello.
Yes,
Go ahead. Go ahead.
Salam, sir. Sir, as per your problem statement, you can go for AI and other models, sir. Instead of going for transformers and other things, you can go for
So your voice is breaking.
algorithms.
Excuse
What
me,
I am
sir.
telling is,
Sir, your voice is
instead
breaking.
of using, instead of using for transformers, you can go in the form of artificial intelligence and other relevant things which are happening recently. So major image capturing technologies are coming under certain platform like deep learning algorithms, machine learning algorithms like that, data science algorithms. So you can also use that knowledge in that scenario, sir.
Sir,
My
but we are
humble
facing, we are
suggestion.
dealing with large amount of data, na? That's so that model is not sufficient. Then go for only transformers. So that's why I'm asking.
Yeah, I am. That's what I am telling you. Deep learning. It's reading with a huge amount of data. Very huge amount of data. It will run 1.5 days or 2 days with the help of a huge machine.
Okay, sir. Thank you.
So you can prefer that model also. Yeah. Thank you, sir. Thanks.
Now I kindly invite participants to ask the questions. If any
Good evening, ma'am.
participants is having, yes, please proceed, sir.
Can you compare the capsule network with transformers?
Sangeeta ma'am. Sangeeta ma'am.
Sorry, I was speaking on mute, Parul. Sorry, yeah. Manoj sir was asking something. Yeah, please.
Yes, ma'am.
Yes.
Ma'am, I want to know the comparison between that capsule network and transformers.
Sorry, your voice has got broken.
Ma'am, comparison between capsule network and transformers.
Capsule network and transformer.
With transformer. Yeah.
Okay. Basically, like we have seen till now how the transformers worked, right? So, there are two components for it. But here, the core component of the capsule network is like capsules are small groups of neurons that encode both the probability of a feature and its post parameters like orientation, size, and position. Whereas transformers excel at processing sequential and structured data by using self-attention. Like these capsule networks are most likely the part of RNA. It's like they are a combination of neurons, whereas this one, the transformers is not like that. And this one, capsule networks, they do dynamic routing mechanism to learn feature relationships or so. And whereas transformers are like works for scalability, large scale data and multimodal tasks. To be precise for you, the capsule networks are more focused on tasks where hierarchical or spatial relationships are critical. Transformers are focused on tasks which require sequential modeling or contextual understanding.
Okay, thank you, ma'am. Can we use that capsule network for sentiment analysis, ma'am?
I would say transformers will give you more accuracy when compared to capsule network.
Okay, thank you, ma'am. Thank you very much.
Thank you so much, ma'am, for having this wonderful session. Now I kindly invite participants to share a few words of feedback, of course, apart from the internet connectivity issue. Any one participant, please share your feedback in words.
Hello, good evening, madam. Hello, is it audible?
Evening, sir.
Yes, sir, you are audible, sir.
Madam, you are given that introduction about that what the LLM and the transformer it will be working. It's a very nice presentation. It will be there, madam. Then other than that, we can have a n number of related different categories. They are using the transformers. Can you give us some example, or you can send any link for that? A different type of perspective it will be there. So if you using the social media, they'll be given the n number of transformers. It will be there. All the thing they'll be asking that subscription. If there is any free subscription, is there, madam?
I will
Or
definitely
you?
send the reference link, sir. And because of the time constraint also, I was able to share only
Okay, madam. Now, because we are using that chat GPT also, we can having the per day, we can having some of the queries, we can do that. Remaining thing, we can put that another login for that using the free sources. That's why I'll be asking that, madam.
I'll definitely give you, the reference links. You can collect it from the
Okay, madam. Last week, you know about that Gemini, they'll be having that one error must be there, madam. One of the student, they'll be asking that some of the topic from that, they'll given that harsh word like that, you can make it as a suicide like that. Is it true or false, madam, depending on the transformers? Is it possible?
I don't think so it is possible, but still, those are machines, so they will get some negative impact as well.
There is no proper training is not that it will be there. But is it so in future it will be there? How you can make this a rectification or of our transformers?
That's why I was saying like you have to do the domain specific fine tuning for sure before you let your model into the market.
Yes, or otherwise you can using that SLM. That's why we can have in the shortest model must be there. Then we can simplest domain we can train some of the things. The already SAR they'll be asking that some of the languages like that. If that they'll having some of the precise word must be there, we can using that normal language model. Normal language model. Other than that, we can small language model. We can use it. We can fine tune your transformers.
Yeah, well
Thank
said.
you, madam. Thank you, madam. That's your presentation. It will be well and good. But some network issue must be there. That we cannot tomorrow onwards. It will be rectified, madam. I think so from the organizers. It's a well and good, madam.
Yes,
Nice
sir.
presentation.
Definitely, this
Is it?
issue will get rectified.
Thank you, madam. Thank you, madam.
Sir. So at the end, I would like to summarize the session. So, ma'am, very well discussed, and explained transformers, BERT, GPT evolution, visual representation idea, case studies, fine tuning of transformers for different tasks, transformers beyond the test, and all the related information regarding to the transformers. So, on behalf of the entire organization team, I would like to extend our heartfelt thanks to Ms. Sangeeta Yamisetti for gracing us with her presence today. Your valuable insights and time have made a significant contribution to this session, ma'am. Thank you once again, ma'am, for your generous support and for being with us today. Now, I would like to invite our coordinator, Dr. A. Anusha, ma'am, to conclude the session.
First of all, I would like to thank to Sangeeta ma'am for accepting our invitation. A heartfelt thanks to you, ma'am, for delivering such an insightful and provoking presentation today. We truly appreciate the effort, what you shared, what you prepared, and everything. We are grateful for the time you spent with us and look forward and future opportunities to learn from you again. Thank you once again. And coming to the tomorrow session, one small gentle reminder to you all. We have again a very insightful and interesting session coming up tomorrow, the same timing at 6 to 9 p.m. So the first session was Introduction to LLMs with Significance in NLP with Kishore Devarseti from customer.io. And another one is, another resource person is Dr. Tingaral Perumal from University of Putra from Malaysia. He's giving the lecture on consumer-centric artificial intelligence of things. So request you all to join on time and make full use of this session. Thank you.
Now I would request to all the participants to switch on their camera so that we can click a photograph. All the participants, please switch on your cameras. I request all the participants to request your cameras, please, to switch on your cameras, please.
Light photo.
Madam, rights is not there, madam. It's not open. Camera is not open, madam. They'll be given that they'll be asking the rights.
No, sir, we gave to all, sir. Please check from there.
It's not
So
open,
we are
madam. Just take them. They'll given that as unable to access camera.
Now you check, sir.
No, madam. This will be given unable to open the camera. They'll given that.
Now
No, madam. It's not be there.
it's coming for all, right, sir?
Now it's
Yeah.
Ram Babu sir, is it done?
Done, madam. Thank you.
Okay, so I just want to remind one more time. We'll be sharing 2 feedback forms for session 1 and session 2 on WhatsApp group. Please fill it before 11 p.m. Please fill the feedback forms before 11 p.m. today itself. Both
Okay,
the
thank
forms will
you.
be sharing on WhatsApp group.
Okay.
Okay. Okay.
Should we leave? Should I leave?
Yeah, thank you so much all the participants to join the session.
Thank you, ma'am.
Thank you all for the time that you have given and the all for concentrating on it. Thank you.
Thank you so much, ma'am. This session was really very nice. I too wanted
Madam.
to ask so many questions.
Madam, feedback link where we can post it, madam. It's not be in the chat box, madam.
Sir, you are not in WhatsApp group, sir?
Yeah, is there, madam.
Then I will share that, sir. We'll
Okay,
share
okay,
that.
thank you.
Session 1 and then session 2 will share there.
Okay, madam. Okay, madam. Thank you.